I'm good to go if you are.
Welcome to Standing for Truth. I'm your host, Donny Budinsky, and tonight we're taking on one of the most talked about challenges in the creation evolution debate: relativity and distant starlight. This is Relativity and Distant Starlight for Dummies, a clear, simple, no nonsense breakdown that anyone can follow. And joining me is researcher and creation apologist Ben Kissling. And together we're going to unpack the science, answer the critics, and show why distant starlight is not a problem for young Earth creation. And yes, we will also be offering a live response to evolutionist and anti-creationist Creaky Blinder's latest attempt to dismiss the overwhelming evidence for a young universe. So get ready. This is going to be an eye-opening, myth-busting, critic refuting deep dive you do not want to miss. Ben, it's great to have you back. Not your first time here on the Standing for Truth platform. You've been here many times in the past, helping us to counter objections, address challenges, and something we really love to do here, refute critics. I've got the majority, I believe, of your programs linked in the description box, but also on the website. You've been here to engage arguments from William Lane Craig. We've engaged just about every argument in the world of old Earth creation and theistic evolution. And so, Ben, how have you been since the last time you were here, brother? I hope your 2026 is going well.
Good. I got to visit family over Christmas break, had a nice long vacation, watched a lot of college football. So that was fun. And I actually talked to my dad, and he said I didn't do as good of a job as I should have on the ASC thing on our last video together, which I actually agreed with that. We had a lot of questions on the anisotropic synchrony convention. So hopefully I can do a better job this time.
Well, you'll do an excellent job. It is a technical topic. So I thought, Ben, my brother, you did a great job. But you know what? You're going to do an even greater job in this session because you've now had over a month or so to prep. I do have a book behind me by Dr. Jason Lisle called The Physics of Einstein, which goes into, which I'm sure you've read and gone over, which goes over the answer from the ASC model to distant starlight. So if we get critics in the live chat, old Earth creationists, or maybe those in the young Earth creation camp that aren't necessarily sold on the ASC model and explaining distant starlight, we are doing this live. Ben is going to be giving a comprehensive presentation. And so after his talk, we will be engaging and interacting with your comments, questions. So send those in. Tag me if you could. I'll save them. We'll address those. JP Uncut, good to see you, brother. Lion and the Lamb, good to see you as well. We'll see if the evolutionists show up with some objections. So, okay, again, structure for the program for anybody just joining us. Ben is going to be giving a comprehensive talk on relativity and distant starlight. A common challenge and objection thrown at us young Earth creationists is distant starlight. If the Earth and universe really are roughly 6,000 years old, how can we see starlight from the most distant stars in galaxies billions of light years away? Doesn't it take billions of years for that light to hit us from the furthest reaches of the universe, hit our eyes? So Ben is going to address that. And again, he's going to be thorough, as we are going to be engaging objections and challenges. So once he's done his talk, we'll take some audience questions. We'll interact with your comments and challenges. And then we will also go through some of Creaky Blinder's latest video that he put out responding to some of the comments we made in our previous video. So, okay, Ben, I think we're going to hand it to you, brother. If you're good to go, we can get your slides up and start your presentation, or however you want to kick it off, Ben.
All right. We good?
Looks good. Relativity and distant starlight. Ben Kissling, slide number 1. The floor is yours, brother.
All right. So here's a quick outline of what I'm going to go through so you can kind of place it in your brain ahead of time. We're going to do a little bit about what the distant starlight problem is, a bit about what time is, interesting topic. I'm going to talk a little bit about reference frames because that's important in relativity. And then we're going to go right into Jason Lyle's solution to the distant starlight problem. And then at the end, I'm going to do a little thing, try to help people explain help people understand in a very understandable way what four-dimensional space-time is, which is a feature of relativity theory. So the distant starlight problem comes from the fact that God says in Genesis chapter 1, on day 4 of Earth time, that he created the sun, moon, and stars, and also that they serve as signs for seasons and days and years. So they're time markers or clocks, potentially. A light year is the one-way distance light would travel in a year were it traveling at the measured two-way speed of light. So a light year sounds like a time, but it's actually a distance. And the basic distance equation is speed times time equals distance. So you can look in our little graphic there. If you've got speed is distance over time multiplied by time, the time values cross out and the equation is valid. And so if you have stars that are billions of light years away, which has been confirmed with many different methods of determining distance, young earthers do not dispute that the long distances. What you get is, well, it should, according to this simple Newtonian distance equation, if we are seeing light from stars that are billions of light years away, it should take billions of years to get here. But if God created the stars 6,000 years ago in Earth time, then distant starlight does not have enough time to get here, and we would not be seeing them if the young Earth view was true, but we can see them. Okay, so I would really recommend John Gideon Hartnett's video and blog post that he did on this back in 2015. This is actually what changed my mind on this issue. Hartnett is an accomplished physicist who has done work with atomic clocks, so he knows relativity theory very well. And in this video, he does a rundown of the 5 different solutions that young Earth creationists have tried. And he says that 1, 2, and 3 on your screen there are potentially legitimate or have merit, and 4 and 5 do not have merit. And that's important to understand because many people at the lay level suggest, often number 4 I hear a lot, is that light must have been created in transit on the way to Earth. And Hartnett does a really good job of explaining why changing the speed of light or creating light in transit are not good solutions to the distant starlight problem. And for that, go to BibleScienceForum.com. That's his website. Just search for brick wall and you'll have 2 results there. One of them will take you to the link to the video where you can hear his nice Australian accent explain all of this. And the other one is a written version. Now, Hartnett's own model is actually number 3 here. And this is what really perked my ears up because Hartnett is downgrading his own model that he worked on for many years. Number two is a model that I used to believe. This is Russell Humphrey's model that used to be called white hole cosmology. He wrote a popular book called Starlight in Time in 1994 on this. And I accepted this for many years. And the first time I heard number one, Jason Lyle's solution, I thought it was crazy. I couldn't understand it. It made no sense to me. I was like, this doesn't make any sense. I don't believe it. I'm going to stick with Humphrey's model. Then I saw this presentation, and I saw Hartnett, who I knew had been working on different versions that are similar to Humphrey's models. And he had basically just come out and said, yeah, here's all my models, but they don't work that great. Lyle's model is better. And so that perked my ears up and inspired me to look into Lyle's model a little bit more and try to understand it better. And so what I'm going to try to do tonight is explain this to you guys in a way that even a non-specialist can understand, which that's what I am. So if I make mistakes, please forgive me. So what's a timing convention? Well, we use timing conventions every day. In fact, we use it when we're setting up this meeting. I'm in Central Time. Donny is in Eastern Time, so he's 1 hour ahead of me. So we have different timing conventions. This is not the same kind of timing convention we're talking about in Relativity, but it's similar to get you thinking about this, where the time value that we were starting this video is 8:30 Eastern Time, but it's 7:30 Central Time. It's the same time, but different numbers assigned to it based on a different timing convention. So keep that in mind. All right, what is time? This is a very deep subject, famously difficult to understand, and very smart people spend many years understanding this. But we're going to go over a couple of different terms and ideas that we need to be thinking about when we think about what time is. For much of human history, we assumed absolute time, and that means that all points in space have the same clock, meaning all points in space are ticking at the same speed. Time is the same value, and it's running at the same speed everywhere. So there's only one clock. It's a universal clock, and anywhere in the universe, physically, you'll be existing in the same time as everywhere else. And this also implies a definition of simultaneity. Events occurring at the same time by the universal clock or absolute time are simultaneous. Relative time, which you can guess has to do with relativity, means each point in space has its own clock. And so the simultaneity of any event is going to be relative to the timing convention that you use, meaning the time at each particular space is going to be relative to that particular spot in space. And so there is no way to say whether some event at a different point in space is simultaneous with the event in a second point in space, unless you use a timing convention to define what simultaneity means. Okay, that's an important concept in relativity, is defining what simultaneity means. There are also two main theories of what time is. The theory that most people assume is true and is sort of intuitive is called presentism. It's also called the A theory or the tensed theory of time. And that is that only the present exists. And we generally just assume this because we can only see the present, right? I'm not looking at the past right now. I'm looking at what's happening right now at one point in time, and it's constantly moving forward. So on presentism, only the present exists. The past doesn't exist and the future doesn't exist. But I would like to plug this episode of a podcast called The Free Will Show. It's not strictly speaking about time, but time comes up. And Catherine Rogers has a really good discussion of presentism versus eternalism, the B theory of time, where all times exist equally. That means the present, the past, and the future all exist in an equal sense. Okay. And a lot of people think this is weird, because this means that if I'm existing in the present, in the past, and in the future, and there's no difference between those existences, how come I can only see the present? All right. And do I exist at all times of my life? Do I exist in the future and the past, like quote unquote right now? It's kind of weird. But Catherine Rogers makes the point that there is no non-weird theory of time. And she quotes, I believe this is a quote from Augustine, that the present is the non-extended point where the non-existent future becomes the non-existent past. And she says, like, that's a lot of nothings to believe in. Because a non-extended point means an infinitesimally small point that has no interval. It has no length, which is, doesn't exist. It's an abstract idea we use in geometry, right? But an infinitesimally small thing can't exist in reality. So a non-existent thing is moving and turning one non-existent thing into another non-existent thing. And there's a lot of non-existent things going on. So how do we know that time is even real on presentism? So there are weird things about both theories of time. Now, relativity uses the eternalism or B theory. And that's the theory that I hold to. But it is less easy for most people to understand. So I'm going to spend a lot of time at the end talking about eternalism. We'll go back to this slide. All right, so what is a reference frame? Well, a reference frame is just an abstract coordinate system like you see on the right, and a simple two-dimensional XY coordinate system that you probably saw in high school algebra. And we overlay it on reality. So it's not real, but we can overlay it on a physical place to do measurements and stuff, like a map. But the reference frame itself does not have physical existence. It's just a coordinate system. Reference frames require an origin point that's 0, 0, the point 0 on the X and 0 on the Y. And if we have higher dimensions, would still be 0 on extra dimensions. And the origin point and the orientation, meaning the angle at which the axes point, are placed arbitrarily. Okay, because again, it's not real. We can place the origin point wherever we want. We can orient it however we want, because it's not a real thing. It's just abstract. It's for our use as a tool. It's not true or false. No reference frame is true. No reference frame is false. It's just a mathematical tool that we use to measure things. And so we can place the origin point and the orientation wherever we want based on what we want to get out of our reference frame, or our coordinate system, it's also called. So an example of different reference frames is the old debate between geocentrism and heliocentrism. I have a graphic on the bottom showing the reference frame of the geocentric theory versus the reference frame on the right of the heliocentric theory. So the geocentric theory uses the Earth as its origin point. And so we say this is the Earth's reference frame. Okay, whereas the heliocentric theory holds the sun constant in space and stable. It says the sun is the origin point of our reference frame, or our coordinate system. And we prefer today the heliocentric theory because it makes it easier to model the solar system. But neither one is true or false. They're both just tools that we use to describe things. And here's a quote from the physicist Fred Hoyle explaining this. It says, "We know that the difference between a heliocentric and a geocentric theory is one of relative motion only, and that such a difference has no physical significance. There's no physical reality to reference frames. It's just we today use the heliocentric reference frame because it's more convenient mathematically, and it also fits with our models of gravity. And it leads to a more accurate model of the solar system than a geocentric one." Now, this is a geocentric reference frame just to show you how it works. You can see that the Earth is stable at the center, at the origin point, and you can watch how the sun moves with respect to the Earth as a stable reference frame, and also the planet Mars farther out. Okay, so this was a model that was used of the solar system for many centuries. In fact, at least a millennia and a half, and it worked pretty well for a long time. So let's move on. So let's ask ourselves, what reference frame does the Bible use? Now, this verse was used for a long time in support of the geocentric reference frame, holding the Earth as the origin point. And a lot of people, on the basis of this verse and some other verses in the Bible, claim that the geocentric reference frame must be true because the Bible said so. Right? So you see, this is the battle that Joshua's fighting, and he asked God to make the sun stand still. So the sun stood still and the moon stopped, and the sun stopped in the middle of the sky. That implies that the sun was moving. And if the Bible says the sun was moving, then it must be true, right? Well, what if the Bible is not asserting that the sun is moving? It's simply using the Earth's reference frame to describe what the people in the time of Joshua saw in a way that they could understand. And this goes to the perspicuity of Scripture. That means the Scripture should be clear and understandable to everybody. And when necessary, Scripture uses reference frames, like when it's describing the motion of the sun in the sky that you see. It uses a reference frame that's known to everyone, not just modern scientists. Why? Because only modern scientists would have understood the heliocentric reference frame. Ancient people would not have understood that. They didn't have that model yet. And so Scripture is not asserting the truth of this reference frame. It's simply using the reference frame to describe things. And we do this too. Whenever you use the word sunset, you're using the Earth's reference frame. That doesn't make you a geocentrist, right? You're just using the Earth's reference frame to communicate ideas that aren't scientific ones. And the Bible is not a scientific textbook. It does not use scientific language, generally speaking. It uses everyday perspicuous language. And because reference frames we know today are not true or false, this means the Bible is not teaching a falsehood. It's just using a particular reference frame to communicate something. Okay. So this book by Max Jammer was recommended on your show, Donny, by John Gideon Hartnett when he came on last year. And he says that let us call the assumption that the event and its perception, so we're talking about a distant event and us perceiving a distant event with our eyes, the event and its perception in the eye of the observer are simultaneous, the visual simultaneity thesis. Okay, this thesis was common to all optical theories in antiquity, and he gives a possible exception after this. Okay, now the visual simultaneity thesis is just the thesis that when you see something happen, that event is happening at the moment, at the instant that you see it. This is just the anisotropic synchrony convention in different words with a different definition. It's the same thing. Okay, so the visual simultaneity thesis and the anisotropic synchrony convention are the same thing, and they were used in antiquity. They didn't have any other conventions. They just assumed that when they saw things happen, the thing that was happening instantaneously or simultaneous with their observation of it. And we do that too in everyday life. I don't calculate how long it took the light to reach my eyes from, when I see something on the TV screen in a football game. Okay, I just assume that it's happening instantaneously with when I observe it. And that's generally a feature of these things that I like to call intuitive theories. They're not scientifically sophisticated, but we use them every day, and we don't believe that we're unscientific for doing so. We're just using the simplest way of thinking about things. There's a lot of examples of these, like we assume that solid objects are full of material, and the best scientific theories say they're actually mostly empty space. We assume that gravity just goes down, when in fact our best models of gravity show that gravity not only goes in different directions, but also is different strengths based on mass, things like that. But we don't think about that in our everyday life. We even use the flat Earth theory. Don't want to make anyone mad, but it's true. Whenever you use a map that does not account for the curvature of the Earth, you're assuming that the Earth is flat. And we used to do this when we used maps back in the day. I had an atlas where we'd go on car trips and we'd just have these flat maps of all the states in the Union, and that's how we got places. And neglecting the curvature of the Earth worked fine for those smaller applications. So we didn't need to complicate life by accounting for it. When you use your Google Maps on your phone, you assume you're using a flat screen. You're neglecting the curvature of the Earth. We do this all the time in everyday life. There's no reason why the Bible can't do this, to communicate things in a way that everyone can understand in all times and all places. All right, so the distant starlight problem, we're going back to Genesis 1, day 4. Let's assume that it is using both the Earth's reference frame and the visual simultaneity thesis, or the anisotropic synchrony convention, meaning we're seeing things from the Earth's reference frame, and anything we see is happening simultaneously with when we observe it. Okay? And if you do that, there can be no distant starlight problem. Okay, why? Because if the event of the light being emitted from a distant star is occurring simultaneously with when we observe it, that means no time passes as the light travels to the Earth. And there's just no distant starlight problem. Okay, now the trouble is going to be accepting that and being like, what? How does that work? But Jason Lisle has done a lot of work showing that this is consistent with our best scientific theories. Okay, so let's look at that a little deeper. So what we know as the speed of light is actually the two-way speed of light, which is measured using a mirror, and it's a physical constant. Now, why can't we measure the one-way speed of light? And last time I was here, Sam suggested a good video from the YouTube channel called Veritasium, called Why No One Has Measured the Speed of Light. They actually mean the one-way speed of light there. Okay, and the reason the one-way speed of light cannot be measured is because you cannot synchronize two clocks that are at a distance from each other without assuming what the one-way speed of light is. Why? Because the fastest way to send a signal from one position to another is using light to send the signal. And if you try to synchronize a clock using that signal, you're using light to do it, which works for everything except light. You can't then use that synchronization that use a light traveling in one direction to measure the one-way speed of light, because that's circular reasoning. Okay, so this is the reason why they use a mirror to measure the two-way speed of light, because you can just have one clock, and obviously one clock is going to be synchronized with itself, and you send the light out from that position, it hits a mirror, reflects back to the same clock, and then you measure what time has passed, and then take the distance that it traveled, and you say, okay, now we've got a two-way speed of light. And this is a constant and has been measured, but you don't actually know what the one-way speed is, and you can't measure it physically. It's impossible, because any attempt to do so involves circular reasoning. You have to assume the one-way speed of light in order to measure it. Okay, and what this means is that in relativity theory, the one-way speed of light is a free parameter. It means we can just choose what it is. It is very similar to the origin point of a Cartesian coordinate system like on a map. You can just put it anywhere you want, depending on what you want to do with it. And that means any synchrony convention, means a simultaneity convention, how we decide which events are simultaneous or not, is empirically equivalent to any other. That means there is no experiment you can do to prove or disprove a simultaneity convention or synchrony convention. There will be no empirical difference between one convention versus another. They will all give you the same results as long as you're doing it correctly. And a lot of the objections to the anisotropic synchrony convention have to do with misunderstandings of relativity theory and how to use different synchrony conventions in the same situation. Most people are taught physics using something called the Einstein synchrony convention. And they think that's just the truth. That's the way physics is. But it's not. It's a convention that was set a long time ago, and virtually all physics is taught using the ESC. And so people have all these equations that they learned that are actually already assuming the ESC. Okay. The ESC just sets the one-way speed of light equal to the two-way speed. Pretty reasonable, right? We measure the two-way speed. Let's just assume that the one-way speed is the same as the two-way speed. Okay. But Einstein and many others have noted that this is not required. Okay. And here's Einstein saying this. The light requires the same time to traverse the path A to M as for the path B to M. That's just the Einstein synchrony convention. Is in reality neither a supposition nor a hypothesis about the physical nature of light, but a stipulation I can make of my own free will in order to arrive at a definition of simultaneity. Okay. So just like a two-dimensional coordinate system or a reference frame, we can choose what the one-way speed of light is, and it changes nothing about the physical reality, changes nothing about the physical nature of light. It's just a coordinate system that we can put anywhere. And we have to do so in order to get a definition of simultaneity on relativity. Remember when I talked about relative time? Okay. On absolute time, all events that occur at the same time as the universal or absolute clock are just simultaneous by definition. But on relative time, under relativity theory, okay, each place has its own clock. So you can't tell what things are simultaneous, what events are simultaneous, without designating a simultaneity convention, what Einstein here calls a definition of simultaneity. And he's saying here that the Einstein synchrony convention is just a stipulation that I can make by my own free will, and I have to do it to get a definition of simultaneity. Okay? The anisotropic synchrony convention assumed that the one-way speed of light towards an observer is infinite, and away from an observer is c, which is the two-way speed, divided by 2. And here you see Lyell's equation that defines this. And if you know your trigonometry, you know if theta, the angle towards the observer, is 0, right, then you will get an infinite speed out of this equation here. Okay. Where if theta is 0, I'm assuming, if I'm remembering this right, the cosine of 0 is 1. That means 1 minus 1 is 0, which means the denominator is 0, and that gives you approaching infinity. Okay, whereas if you set it at 180 degrees, right, or I think it's pi in radians, you'll get, I guess, 2, I think that's how it works, or I don't remember. But anyway, that's the equation that you use to determine the one-way speed of light at an angle from the observer. But the important thing for us is that it's infinite towards the observer. Okay, another interesting thing about the ASC is that it's a little different in terms of how you would explain it. to people. So this is coming from Lyle's 2010 paper in the Answers Research Journal. So you can look that up. Just go to the Answers Research Journal and type in the anisotropic synchrony convention. You should find this. So when people learn about relativity theory in school, they will get these thought experiments that Einstein used to explain it, including things like the moving train thought experiment and things like that. Okay. Those thought experiments show, right, that how two observers measure simultaneous events will be different if they have different velocities. Okay. So that means that your simultaneity convention on the ESC, on the Einstein synchrony convention, is dependent on velocity, but it's independent of position. So actually, if on the Einstein synchrony convention, if you have two observers at a distance from each other, as long as they're moving with the same velocity, which is speed and direction, okay, the velocity, if they're moving at the same velocity, they will agree on the same two events, whether they're simultaneous or not. But if they're in the same position, even, and they're traveling at different velocities, they will disagree on the same two events being simultaneous. One might say they're simultaneous, and the other one that's moving with respect to the first one will disagree and say they're not simultaneous. Okay, so it's a definition of simultaneity. But on the ASC, it's exactly the opposite. On the ASC, simultaneity is, make sure I get this right, is dependent on position, but independent of velocity. Meaning that on the ASC, two observers at the same position will agree on what two events are simultaneous, even if they're at different velocities. Okay, so it's like ASC and the ESC are two extremes of a long spectrum of an infinite number of possible conventions, where on the ESC, simultaneity is dependent on velocity but independent of position. On the ASC, simultaneity is dependent on position but independent of velocity. Okay, so a lot of these thought experiments that you can go look up yourself, I didn't do a lot of this in this presentation because this is very easy to find on YouTube and other places. You can go learn about relativity. A lot of those thought experiments don't apply to the ASC. Okay. Now, the simple speed equation that we looked at earlier shows how the ASC works as the speed of light approaches infinity. Okay, so when you're using the ASC as a simultaneity convention, speed of light towards the observer is infinite. Okay, so simultaneity means the time between two events is zero. And so if you've got an infinite speed in this equation and time being zero, turns out distance doesn't matter, right? With zero in the denominator, you're going to get an infinite speed for any distance. Doesn't matter what the distance is, okay? And so that means on this timing convention, we are seeing the stars in real time, regardless of how far away they are. All right, so Lyle makes it pretty clear that there are two different ideas here. The ASC convention does not make testable predictions and cannot be falsified. The different timing conventions on relativity are empirically equivalent. You can't test them. They will give the same results regardless of which one you use, as long as you're doing it correctly. However, the ASC model goes beyond the mere convention and does make testable claims and is therefore falsifiable. Okay. Now, how does the ASC model go beyond the ASC convention? It adds data from the Bible. Okay. It adds the idea that on day 4 of Earth time, that's when God created the sun, moon, and stars. And it suggests that God is using the ASC when he makes that statement. Okay, he's using the ASC, which is the ancient simultaneity convention, which Jammer called the visual simultaneity thesis. Okay. And that makes testable predictions. When we look at any region of the universe, we are seeing it at an age of roughly 6,000 years. Okay. If the ASC model says that light reaches the Earth instantaneously from any distant star, that means that on Earth time, those stars are all 6,000 years old. So the ASC model predicts a young universe. Now, this is different than Humphrey's model that I used to hold to before 2015 or so. On Humphrey's model, he says that distant stars actually are several billion years old or whatever by their clocks. Okay, but the Earth clock is only 6,000 years. On Lyell's model, everything in the universe is roughly 6,000 years old. Okay, now roughly, not exactly, because there's still time dilation due to gravitational effects and things like that. So they won't all be exactly the same age, but they'll be close. Now, Lyell has made some successful confirmed predictions of findings from the James Webb Space Telescope based on the ASC model. He predicted galaxies at higher redshifts. He predicted fully formed galaxies at higher redshifts. We'll talk about what that means. And evidence of heavy elements in these galaxies. And opposed to the Big Bang model or the old Earth model, that galaxies should not be around, or at least we should be seeing mostly young galaxies at higher redshifts. Okay, that's 1 and 2. And there should be at least some stars that have no heavy elements in them. Now, last time I kind of explained what that meant, but briefly, on the Big Bang model, the Big Bang model does not give you any elements heavier than lithium. So you've got hydrogen, helium, and lithium. That's 1, 2, and 3 protons in the nucleus. Okay, and so the only way we have heavier elements. So how did they get here if they didn't come from the Big Bang? Well, the Big Bang model goes forward and it says, okay, how do we get these heavier elements? Well, the first elements combined into these population 3 stars, and then they went and they did some fusion in the center of the star and created heavier elements. And then they went supernova and spread the heavier elements around. Then those heavier elements formed population 2 stars, did the same thing, formed even heavier elements, and they exploded and then formed population 1 stars like our sun. Okay, but the earliest stars should not have heavy elements in them. And if you look far enough into space on the ESC convention, that should be the same thing as looking that far back in time. So if a star is 1 billion light years away, we should be seeing an image of that star from 1 billion years ago. Okay, and so if you look far enough away, you should be looking close enough to the beginning of the Big Bang to see earlier galaxies, which are not well formed, younger galaxies, and galaxies or stars with no heavy elements. And they haven't seen any of these things. In fact, this has so shaken the Big Bang model expectations that they are now busy trying to figure out how to change their models around to accommodate this. And they haven't decided on any particular one yet. One that they've been throwing around is there's something about galaxies called the initial mass function, and they can play around with this and change it and try to match it to what they're seeing from the James Webb Space Telescope. But before that, they were just using the initial mass function that they were using for all the galaxies around. And they just assumed it would be the same if you look farther away. Okay. And all Lyell had to do was say, well, there's nothing special about the galaxies that we can see because they're close enough, and the galaxies that we can't because they're just too far away. So I would expect to see the same things farther away that we see closer by, near to us and everywhere else. Galaxies that have spiral arms or full disks, which on the Big Bang model or the old Earth model, they expect those to take a long time to form. But Lyell believes they were created pretty much as they are on day 4. Okay, and so he just said, we're going to see the same things we see everywhere else. And he was correct about this. And this is a real prediction. He made this prediction in 2021, and the results of the James Webb Space Telescope came out in 2022. And if you read the 2010 article, Lyell doesn't make predictions about the James Webb, but he does show that the model does predict this way back in 2010, at least. And if you want to read more of Lyell's discussions of this, go to his website at biblicalscienceinstitute.com. He does engage some common objections there in articles. Okay, I talked about this last time, but briefly, I have engaged some PhD astrophysicists on the ASC. This is me personally talking to them, confirming that Lyell is correct about this. Because note, this gal says in a research paper, I'd be forced to say it's an arbitrary choice, meaning the ASC, or the choice of simultaneity convention, or synchrony convention, because absolute simultaneity doesn't exist in the relativistic framework. So you have to choose a convention for simultaneity. Technically, the one-way speed of light depends on the synchronization choice, and there's no way to prove it's the right one. Okay, this is Luke Barnes, published in the Answers Research Journal, actually, saying that this gives the model enough freedom that any observed population galaxies is consistent with the young universe. In that case, one might as well attach the convention to the Big Bang model and be done with it. He's talking about the anisotropic synchrony convention. Now, I recently talked to Luke Barnes, and it's kind of an awkward conversation on Facebook, and he was arguing that this means that the ASC makes no predictions and has no constraints. But he needs to go and read Lyell's papers on this as well. Lyell says the same thing in his book, and he distinguishes between the ASC convention and the ASC model, which adds additional information and can make predictions. Okay, so we are moving into 4-dimensional space-time, a very counterintuitive idea. Okay, but we're going to start in 2 dimensions. Okay, and note that as I explain this, what I'm going to explain to you is not relativity theory. What it is it's a way that I think I can help people understand some concepts in relativity theory in a way that is understandable, that should be to anyone with a high school education. Okay, so this is a 2-dimensional Cartesian coordinate system, and I have 2 points here. One point is at x coordinate 1, which will be the first coordinate here, and y coordinate 1, which will be the second coordinate. And then I have a second point, which is at x coordinate 3 and y coordinate 1. Okay, you should recognize this from high school algebra. Now, we're going to say that these 2 points are real points in an actual space. So we're going to say the green point is my house, and the red point is the illustrious and fabled Memorial Stadium, where the Nebraska Cornhuskers play, the greatest college football program of all time. Obviously, everyone knows this. And so these are 2 points in real space. Okay, so we can't mess around with reality. Reality is reality, whether we like it or not. We can't make some kind of arbitrary choice and change the position of my house or change the position of Memorial Stadium, right? They have to stay where they are. But what we can do is we can change the coordinate system that we use to describe their position, okay? Now, another thing that has to stay the same is the interval between the 2 points has to stay the same. If the physical locations don't change, then the interval between them must not change either, right? Okay, in this case, on our little graph here, the interval is 2 units. You can imagine whatever unit you want, miles, meters, any distance unit, doesn't matter. Okay, so the interval is 2 units long. Okay, so the things we need to keep the same when we change to a new coordinate system, which we can do because the coordinate system is abstract, whereas the points on the map are real, right? So our numbers are not real, they're abstract. the axes, the X and Y axes are not real. The grid lines are not real, but the 2 points and the interval between them are real. Okay. The origin point is a free parameter. We can choose where to put it. So what am I going to do? Well, what happens if we move the origin point? Nothing will change physically. We already talked about that. The interval between the 2 points will be constant. We'll have a new reference frame. So right now we're in this reference frame. And when we move the origin point, which we're going to do, we'll have a new reference frame. But in order to keep the physical locations of the real things the same, we're going to have to do something called a transformation. Well, what is a transformation? This is just changing the coordinates from the old reference frame to the new reference frame so that the physical position of the points remains the same. Okay, so when we move the reference frame or the coordinate system in the new reference frame, we're going to have to change the actual numbers of the coordinates. That's what a transformation is. All right, so what happens if we move the origin point 0, 0, 1 unit to the left? So we're going to take the origin point 0, 0, and we're going to pretend in your mind that you're dragging it 1 unit left, but the green and red points and the intervals are staying in the same position. Okay, so we're going to drag the origin point 1 unit to the left. What does that look like? Okay, and when we do the transformation, that means we have to add 1 to each x coordinate. Okay, so if you think about it, even though we're moving in the negative x direction, like this, okay, you see what I did there? I moved the origin point 1 unit to the left, and that's in the negative direction, but because these guys have to stay in the same position, we're going to add 1 to their x coordinate. Okay, so there's the old coordinates. We're adding 1 only to the x coordinate, and that gives us the new coordinates, and we've just done a transformation. Now notice that the coordinates of each position are different in the new reference frame, in the new coordinate system. Okay, but the physical position of the 2 points is the same. It's only the coordinate system that we have changed. And the interval is the same. It's still 2 units, as you can clearly see. All right, what happens if we move the origin point +2 in the y direction? So 2 units up. Well, let's do that. That means we're going to subtract 2 from both y coordinates. Okay, so let's do this. These are our new coordinates in the new reference frame. Now we're going to subtract 2 from the y coordinates this time. That's our new coordinates in the new reference frame. So what does that look like? It looks like this. Okay, see what I did? I moved the origin point up 2, and that means that these guys are still in the same position and they have new coordinates. And the interval remains the same. All right, what about 3 dimensions? This is 2 dimensions. X and Y are 2 dimensions. What if we do 3 dimensions? Imagine a z-axis that's going into the screen, away from you, and out of the screen towards you. That's our 3rd spatial dimension. So we've got height. Height is y, width is x, and depth is z. Can we do the same thing? Well, yes, we can. I'm turning into Barack Obama here. Yes, we can. Now notice that the coordinates have 3 numbers. There are 3 coordinates now because we're in 3 dimensions. So the first one is x, second one is y, third one is z. And right now we're just going to say initially we're at the 0 coordinate on the z-axis. Okay, but let's do a 3-dimensional transformation. Let's move the origin +1 in the z direction, and let's say that is into your screen. Okay, so we're going to move the origin point into the screen along the z-axis, which is imaginary. Could have drawn this, but I'm not a good drawer, so you'll have to imagine it. That means we'll have to subtract 1 from both z coordinates, just like we did before. Okay, so we're going to subtract 1 from both z coordinates, and we get our transformation in the new system. Okay, hopefully you can imagine this in your head, and it works exactly the same way. But notice that the mathematical operation of a transformation is exactly the same in 3 dimensions as it is in 2 dimensions. It's just we have an extra coordinate, that's all. So what about 4 dimensions? Well, in relativity, we treat time as though it is a 4th dimension, no different than the other spatial dimensions. Okay. Now, in real physics, there's some differences, but we're not going to talk about that. Basically, it's a 4th dimension. Time is. Now, we can't actually make a graph of this. We can draw a graph of a 3-dimensional coordinate system using perspective, but no artist in the world has good enough perspective to draw a 4-dimensional graph. We can't do it. We don't know how to do it. We can't visualize it. Okay. But even though we can't draw a graph of it, we can still do a transformation in exactly the same way, and it is very simple. The other difference is that the points, before we were talking about points in space because these are spatial dimensions. Now we're talking about events. We're talking about an event that occurs in space, but also in time. Okay, so it's an event, not just a point in space. All right, so there's our 4-dimensional coordinates. The 4th one is the time coordinate. We've got X, we've got Y, we've got Z, and now we've got the T dimension, or time. So what if we move the origin point +1 in the T direction? Just like we did before, just don't worry about trying to visualize it this time. We're just going to do the math. We're going to subtract 1 from the T coordinate and get the result. And there we've done our transformation. Okay, so it works exactly the same way. Now, we should expect all the same things to be true in 4 dimensions as in 3 dimensions, which were the interval, now called the space-time interval, between the 2 events, right, in 4 dimensions, remains the same. So the space-time interval is a new kind of interval that takes into account a time coordinate, and it remains the same, even though all 3 spatial dimensions and the time dimension can change the numbers associated with them. Their coordinates can change, but the space-time interval remains the same, just like the distance interval remained the same in 2 dimensions and 3 dimensions. Nothing about the physical system changes, meaning we're not changing the physical nature of light or the event of the Huskers beating Ohio State in our home stadium. This is a fantasy of mine. So it didn't actually happen, but it will happen in the future. Okay. Nothing about this system changes. The game still happens at the same time, but the time coordinate has changed potentially. The time coordinate changed when we did a transformation to a new reference frame, and this is the weird part. When you change your simultaneity convention, the time coordinate changes. Okay, so a game that happened at 1 o'clock now happens at 2 o'clock or something like that based on your simultaneity convention. All right. Under relativity, the time dimension is no different than the 3 spatial dimensions. We already talked about that. In our demonstration, which remember is not relativity theory, it's just demonstration, the origin point of the graph is the free parameter. Okay, we can change that however we want. But in relativity, it's the one-way speed of light that's the free parameter. We can change it however we want, and as long as we do the transformation right, nothing changes about the physical system. Okay? The timing of events will change, but nothing actually changes about the physical system. That's what happens when you treat time as the 4th dimension. It is just a dimension. It doesn't denote anything physically real, okay? So this means that the time coordinate of any event can be arbitrarily changed based on the free parameter of the one-way speed of light. Which means that's just what Lyell's doing to solve the distant starlight problem, right? He's just changing the timing convention. And that means that if God was using the ASC when he wrote Genesis 1 or inspired it, he's just saying, I created the sun, moon, and stars on day 4 of Earth time using the ASC timing convention. And there's no problem with distant starlight. Okay, because the time at which the light leaves the distant stars is simultaneous with the time that we observe them in Earth's reference frame. All right, so let's go back to this slide and look there at the bottom at eternalism, or the B theory of time. If you think about time as a coordinate in a four-dimensional graph, right? All time coordinates exist in that graph, in that four-dimensional space, and there's no preferred time coordinate. There's no preferred time. Okay, so relativity entails eternalism, or the B theory. All times exist equally because they all exist on this sort of imaginary four-dimensional graph, or this four-dimensional coordinate system. Okay. But there's still this weird question about it. Like, why do we see only the present? And do I exist at all times in my life? Well, that's still weird, but I have some way that I like to think about understanding this. So we're going to use a common thought experiment. It's a famous one called Flatland, where we have this two-dimensional world where there are people who live there. They're two-dimensional beings. And we have Miss Circle and Mr. Square. And I'm a giant chauvinist pig, so I represented Miss Circle as pink and Mr. Square as blue, so sue me. But there's something wrong with this picture. If Miss Circle and Mr. Square are really two-dimensional beings, would they really look like this? Think about where their eyes are looking at. They're looking out at you, which is a third dimension. But the third dimension doesn't exist for them. They only exist in two dimensions, so they can't actually look out at you, right? The third dimension, the z-axis, doesn't exist. So we have to draw them like this. They're looking at each other. They're checking each other out. I think the one is thinking the other one's cute. One is thinking the other one's hot. They're thinking about getting together. Okay, they're looking at each other. That's where their eyes are, right? They're on the outer edge of their two-dimensional flat bodies. Okay. But if you think about it, if you were Miss Circle or Mr. Square, what would you see? If you're looking out into the world with your two-dimensional flat eyes into the two-dimensional world, what would you see? Well, in fact, you would see just a flat line. That's all you'd see, right? If you can think about it, put yourself in Mr. Square and Mr. Circle's position, looking along this two-dimensional plane, you would see a flat line. But a flat line is just a one-dimensional object. Okay? So we can conclude that two-dimensional beings only see in one dimension. Interesting. Why would that be? Well, it just seems to be the case. So let's make a general principle out of this. Let's say that n-dimensional beings see in n-1 dimensions. Two-dimensional beings see in 1D. Three-dimensional beings would see in 2D. Four-dimensional beings would only see in 3D. And oh, look at that. How many dimensions do we human beings see in? We see 3 dimensions. We see height, width, and depth. We don't see time. We don't see the 4th dimension. Okay? We can't see time passing. We can move through time, right? But think about Mr. Square and Miss Circle. They can move through the 2nd dimension too. They can, Mr. Square can move 5 units down, and Miss Circle can follow him because she's starting to like him, and they can move within the 2nd dimension, but they can't see it. They can only see 1 dimension. We can also move in the 4th dimension in time, but we can't see it. We see in 3D, we must be 4-dimensional beings. Whoa. Okay. That's kind of the end of my presentation. That's just a way that I hope people can understand maybe even some evidence that we're 4-dimensional beings, that is real, and also understand how 4-dimensional space-time works and what it means when time is just a coordinate. It's not a feature of a physically real feature of a physical system. So I am done with my presentation.
Ben, that was excellent. That was a quick hour. Great job. I think your dad would be proud of the way you engage that topic and the predictions, fulfilled predictions by Dr. Jason Lau. Let's keep the momentum going. We got a ton of comments that are going to keep you busy, Ben, until same time tomorrow. So get a pot of coffee going. You're going to be answering challenges and questions all night. So that's good. There's a lot of excitement here from both critics and non-critics in the chat. And so let's start at the beginning. A few of these points you addressed, but I think it's important to reiterate some of these points, and then we can also get some shorter clips out there too to further promote what you're doing here, Ben. Okay, let's start with this one. It's more of a comment, but Andrew Cumming, one of our resident critics, and we do enjoy and believe it's important to address criticisms and challenges. So he says, ironically, the ASC model of a young universe pushes things back to essentially light in transit, at least for objects of variable luminosity, colliding galaxies, etc. Any thoughts, Ben?
I don't agree, because on the ASC model, light is traveling towards the Earth's reference frame at an infinite speed, which means it actually did leave the distant star, right? It actually really was generated by the distant star, and we really saw what really happened, right? So we're not seeing fake images like in the in-transit model. The in-transit model has a problem because essentially makes God a deceiver, because he's sending us images that he creates in the light in transit, and we see those images, but they never happened. In fact, none of them ever happened for light that's more than 6,000 light years away on a young Earth view. And that means the vast majority of what we see from the heavens on the in-transit model never actually happened. On the ASC model, they did happen, right? That's a huge difference in my opinion. And I'm not quite getting what his point is about objects of variable luminosity is. They're just the same thing as distant stars. We'll see the image of them in real time. So I'm not sure what the point is that he's making there.
Is he saying, and perhaps Andrew, if you're listening, you can clarify a little bit, variable luminosity? So is he saying some galaxies or some stars are brighter than others? I
guess, but I don't know. I don't know what difference that would make.
Right. Okay. No, I think you answered that good. Well, I've taken a lot of notes based on the material of your presentation and the topic in general. To reiterate, and maybe we'll do it through a question, is it accurate to say, and I think this will clear some stuff up that I've seen in the live chat, although we'll give the critics the benefit of the doubt, they're largely commenting as you're presenting. So you address things later in your presentation that are brought up earlier. And so, Ben, is it accurate to say that the ASC model, this model in explaining the distant starlight challenge, is grounded in standard relativity, not new physics? We're not dealing with new physics here. ASC is not speculative. It is a recognized option. It is a legit option within Einstein's own framework.
Yes, that is correct. And Lyle has references in his book, The Physics of Einstein, and in his articles, especially to a physicist named John Winnie, who published on this in the 1970s and proved that not just the ASC, but any other synchrony conventions are all empirically equivalent under standard relativity theory. So this doesn't require any new physics, like the other numbers 2 and 3 on Hartnett's list. Both of those options tend to require new physics. Lyell's model does not. In fact, the only thing that's different about it is that it uses a different convention than most people learn in their physics class when they learn relativity. And that throws people for a loop. It threw me for a loop when I first heard it. But it is not new physics. It is empirically equivalent to every other convention, including the ESC, the standard one. And there's you really can't argue against the ASC convention. As Lyle said, you could make arguments against the model because the model introduces additional information, primarily from the Bible, right? And that's not part of any standard or conventional physics, right? Is they reject the Bible. But the ASC convention, it's pretty standard.
So the ASC model then solves the distant starlight problem without violating scripture, physics, or science in general. And it doesn't require exotic cosmologies, stretching time, or even light created in transit, contrary to what Andrew was saying, which I think makes it a powerful explanation, in my opinion.
Yep. And I can, after I kind of understood it better, I easily understand why Hartnett switched to that position, even though he was still working on his own alternative models. And he was like, this model is so much better than mine. I'm just going to have to admit that it's better.
Right. He discovered a superior model. And for that reason, he abandoned a previous model and we've had him on here many times in the past. He's a blessing and extremely knowledgeable on these topics. And one of my first books as a creationist was his book, Debunking the Big Bang, where he was arguing for, you probably have it. Yeah. Dismantling the Big Bang, I think it's called. Yeah.
Dismantling the Big Bang. Yep.
Yes. So I think he was arguing for white hole cosmology, and he's seen why the ASC model is more powerful. Okay. So here's a comment. I'm curious as to your thoughts. Perhaps you can give us a good picture of why Dr. Phillip W. Dennis, and on Dr. Jason Lyle's website, perhaps for more context, I can screen share real quick just to provide the context. So this is Jason Lyle's website, Biblical Science Institute. We've had Dr. Lyle on a couple times discussing the ASC model, and he always does a phenomenal job refuting objections. So for anybody unfamiliar with what's going on in this back and forth, Ben, Jason Lyle, he's published several clearly refuting Phillip Dennis's errors in physics, ASC part 5, part 4, part 3. So he's not playing around. And each one of his articles are detailed. So he's very thorough. And I appreciate that about Dr. Lyle, but the ASC model in general, as Dr. Lyle and proponents of ASC like yourself, Dr. Hartnett, Dr. Lyle, you guys don't seem fazed by the criticism. So I think that's pretty cool. And so, okay, to go back to the comment here, Phillip W. Dennis apparently presents an internal contradiction of Lyle's ASC model. Can you maybe speak to this, Ben, for a little bit?
Yeah, that's the name of an article that Dennis published in the Answers Research Journal. So they've gone back and forth on this in the ARJ. I've read those articles. I've watched Dennis on some other shows. And, I tried to give him the benefit of the doubt. But it's like there are several points in his presentation where I was sitting there thinking, even without a knowledge of relativity at all, like I've not been trained in relativity except for what I've read in Lyle's book. But I saw Dennis basically using a bunch of equations. I think they were about like synchronizing with GPS satellites or something. And he was pointing to the term c, which is the constant that's the measured two-way speed of light, and pointing to it in the equation and saying that's the one-way speed, because he thinks that in that particular equation, c suddenly has changed from the two-way speed to the one-way speed because of the way he's using the equation. And I was like, I just with my limited knowledge of physics, I know that's not a legitimate way of deciding what terms mean in equations. The term means what it means when you started using it. Just because you do a derivation in another and come up with another derived equation doesn't mean the term changes what it means. In fact, you have to keep it the same, or you're not doing mathematics correctly. But he was trying to argue that in this equation, c is suddenly the one-way speed when it starts out as a two-way speed before you derive it. And that's just a simple one. Lyle didn't even mention that, but Lyle's basic argument against Dennis is that Dennis is using standard equations in standard physics textbooks that already assume the Einstein synchrony convention. And in his first response in the ARJ, I think it was his first response to Dennis in the ARJ, Lyle showed how you have to go back farther to the basic equations of relativity that do not assume a particular simultaneity convention or synchrony convention. And then he showed where the equations that Dennis was using come from if you assume the ESC, right? And so if you assume the ESC, you can derive these other equations, and those are the ones that get into the textbooks that Dennis is referring to. So he just doesn't know relativity theory enough to realize that those equations already assume the ESC. And so if he's using those equations to prove the ESC, it's a circular argument. Because the premise in, the garbage in, garbage out. It's you put the ESC in there already in those equations, which Dennis didn't realize because he didn't personally derive those equations. Lyle showed how to do that. But when you put the ESC in, you get the ESC out. That's not really surprising. So there's a lot of other issues involved with this. I'm kind of looking forward to the part 6 because Lyle's going to talk about eternalism. And I really think that this is why I focus so much on eternalism and four-dimensional space-time. It's because you can get a standard explanation of relativity theory, at least with Einstein convention, on YouTube almost anywhere or on the internet. You can go look that up on your own time. What I was trying to do was explain how eternalism and four-dimensional space-time works within relativity. And I really honestly do think that Dennis's objections to the ASC are really objections to eternalism, because he says things like eternalism is not biblical, and he makes theological arguments against it. And even at the time when Einstein came up with this in the early 20th century, there were similar objections. There were philosophical objections to this. People were saying, oh, this can't be right because there must be absolute time, and all kinds of other objections, right? William Lane Craig, for example, studied time for 7 years or something, wrote a book on it called Time and Eternity. Yeah. He rejects relativity theory, at least the standard relativity theory, because he thinks philosophically there has to be such a thing as absolute time. So lots of people have objections to relativity theory. That's fine. You can have those debates. I'm not as strident about that as Lyle is. But the problem that you have is not with young Earth creationism. The problem that these people have, including Dennis, I think, is with relativity theory. And that's fine if you have that problem, but what it means is that young Earth creationism does not have a scientific problem here. Now, if you have a philosophical problem with science, that's fine. I think that's totally legitimate to have that discussion, but it's not a scientific problem with young Earth. Another thing that Dennis says is he's trying to offer his own alternative model. And he says it's based on general relativity, which is supposed to be better because it includes gravity. Well, that much I know is kind of weird. Because special relativity is just a special case of general relativity. It's the case where space-time is flat, which means there's no gravitational wells in it. There's no masses in it that creates gravity. And Dennis says, well, because we're using general relativity, we're introducing gravity, and that makes it better. But the concepts are still the same. It's still the same theory. Lyell doesn't have to make a whole lot of adjustments to his theory. In fact, he basically says in the 2010 paper, I'll just assume that gravitational time dilation is negligible, and it still works just fine. But it doesn't have to be negligible. If it isn't, it isn't. There are gravitational time dilation effects introduced by mass and gravity, but it's not going to dramatically change the model. And Dennis is claiming that it does. And there's been a few times where Lyell just asked him in writing point blank, Dennis, do you have a problem with relativity theory in general? Because it sounds like he does, but then he goes and he refers to general relativity when he presents his alternative. So it's kind of, I think Dennis is confused.
Yeah, well, I was thinking with the original point there, and the first criticism that it is circular reasoning. You pointed that out. And since the ASC model, from my understanding, is logically and mathematically coherent, it makes predictions identical to standard physics for measurable phenomena. Therefore, my question is, have you noticed that typically when there are attacks from critics, it's usually not based on the science of the issue or the logic or math of the issue, but they attack it emotionally, since the model, and I'm not saying Phillip Dennis is attacking it emotionally. He seems like he's got, you mentioned eternalism and some issues he has there, but because the model works, the critics can't really attack it logically or scientifically, Ben.
Yeah. A good example of that would be Luke Barnes, which we had that awkward Facebook conversation, which I know you saw.
Yeah.
Where I had to ask him like 3 or 4 times, have population 3 stars been observed? And he wouldn't answer.
Right.
He finally answered and said, no, not definitively. Like, okay, you could have just answered the first time, but
started off with that.
And then he tried to, Luke Barnes is an astrophysicist, so I have to defer to his expertise on these questions. And so I was trying to be very respectful, but he wouldn't answer a simple question because he knew that the answer didn't favor his view.
Right.
And
it didn't favor the science of his view from an old Earth perspective. It was contradictory to it, right?
Yeah, and I think Barnes is trying to argue that the ASC makes no predictions at all, and therefore, why can't Lyell? He says in that quote that I put in the presentation, that's in an article in the ARJ. Why can't Lyell just use the ASC and take everything else from the Big Bang model? Well, it's because he's not just using the ASC convention when he makes predictions. He's using a model that includes information from the Bible, and that does make predictions. So there's a distinction there between the concept in relativity theory of the relativity of simultaneity, which I would want to see Luke Barnes, whether he affirms that or not, and that would tell us a lot. Which means that if he's attacking Lyell's view as being unfalsifiable, then he should also attack his own view for the same reason, because that's just how relativity theory works.
Well, and that's a point that I see frequently, Ben. I see it in the live chat here. So maybe we should deal with it directly, just to show why it's not really an issue that we should be overly concerned with. So here it's the same comment that the ASC model is an unfalsifiable and untestable model. Therefore, it's simply not science. That's why people poke fun at it. And apparently they compare it to last Thursdayism. And so what is the best way to address that, Ben?
I mean, last Thursdayism claims that, well, it's sort of a argument ad absurdum that what if everything was created last Thursday with the appearance of age. So I think you might be referring to, so Lyell does say that because distant stars and galaxies were created on his model 6,000 years ago, roughly, that means they were created roughly as they are. 6,000 years is not a long time in astronomical terms. And because old earthers are so used to trying to come up with billions of years of evolution and changes that galaxies would undergo over that amount of time, and modeling it and everything, and showing how, you know, spiral arms would form or something, all these theories about how these things happen, which we've never really observed those processes over billions of years. They're all theoretical. The old earthers think that these things are just true. That means that a galaxy with spiral arms must be billions of years old, because spiral arms have to form over time. Well, Lyell's view entails that God created galaxies with spiral arms already. And that means that, well, it's an old, mature galaxy that God created with the appearance of age. But God is not responsible for our false assumptions about how long things take or how things evolve over time. We made those things up, okay, because we rejected the biblical chronology. God already told us what the biblical chronology is. He already told us when he created stuff, okay? It's not his fault that he wanted to create different kinds of galaxies because he's an artist. It's the same reason he created different kinds of animals. He wanted to create different kinds of animals because he's an artist. He likes doing that stuff. And he does it for our benefit and probably for his own pleasure. And so he created different kinds of galaxies, some with spiral arms, some are disks, others are nebulas and all sorts of things. Created them all that way. And then we come along, and after we reject the biblical chronology, we start making these speculative theories about how long these things take to form, and then come back at God or the Bible and are like, well, you created it with the appearance of age. No, he didn't. You created the appearance of age with your own models of how things evolve over time. God's just creating art. So, and some of this gets back to, you know, anyone who believes that Adam and Eve was created as adults believes that God created Adam and Eve with the appearance of age, right?
It's not like he created Adam and Eve as zygotes or babies. Adam to till the ground as a baby, you know?
Yeah, anyone who believes in the special creation of any kind believes that God created with a so-called appearance of age. But good thing we have the Bible, so he tells us, hey, I created it then. And if you just trust that, then you don't need to be like, oh, well, it's an appearance of age. Of course, he had to create Adam and Eve as adults. He couldn't put a couple of babies on the earth to fend for themselves. But this isn't last Thursdayism. This isn't arbitrary. This isn't me. This isn't us saying that, well, there's no difference between anything that we're saying and having created the universe last Thursday. Our view is based on a historical record, a credible, accurate historical record. And we can't just say it was based on created last Thursday, because that's not what the Bible says.
Well, I think you made a really important point there that I'd like to reiterate, that a lot of old earth creationists would say that an appearance of age, or God creating the earth and Adam and Eve and the original created kinds functionally mature, is deceitful. But it's not. You just nailed it, because God told us in his word, holy men spake as they were moved by the Holy Ghost, the Bible, that God created by the power of his hands. He created in 6 literal days, 24-hour days. And so it's not like God's being deceitful, because he told us. And then he warned us in 2 Peter 3 that in the last days there's going to be scoffers denying his mode of creation, specially created, the flood, which explains a lot of the phenomena that we debate, a lot of the observations. So we're warned in scripture that people will deny these events in history, like the creation and the flood, that actually explain a lot of the data that we see. And so how would you address this, Ben? What testable, falsifiable prediction does this model create?
Yeah, I just want to say one last thing on this. You reject what God told you and then complain that he didn't tell you.
Right. Yeah.
It's like, what else is he supposed to do?
Mm-hmm.
But as for testable, falsifiable predictions, I showed some of those in the presentation. I don't know if this comment is before that or not, but
I can put it up on the screen for you.
Are you seeing it?
Yes. Yep.
Oh yeah, there we go. Okay. So here they are. Okay, and you can go to Lyle's article on his website, which is at the bottom here, and look up, I think it's under a topic called Big Bang Refuted or something. And there's an article called Creation Cosmology Confirmed. And that's the one he published after the James Webb results came out. And it has a link to the article that he wrote before that, which I forget what it's called. But in those articles, he predicts galaxies at higher redshifts, which has been observed. And he defines that. Fully formed galaxies at higher redshifts, again, correct, successful prediction, and evidence of heavy elements in these galaxies. Those are the three confirmed predictions. And he made another prediction that's not really a scientific one, but it was a prediction of what the Big Bang people would say when the results came out and didn't agree with their expectations. He predicted they would say things like, well, galaxies must have formed much earlier than previously thought.
Right.
And lo and behold, we see all kinds of articles like that coming out in different ways. And Lyle predicted that nobody would change their minds because of this. What they will do is they will change the model to fit the data. Okay. And that's totally legitimate scientifically. Okay. But they expected something else. And now they're having to change their model. Lyle doesn't have to change his model. Okay, it works just fine. Like I said when I talked about this in the presentation, Lyle expected these things because there's no particular reason to expect anything different at higher redshifts on Lyle's model. He would expect to see all the same things as he saw before. It's no different than the assumption that if you turn your telescope to a different place in the sky from Earth that you haven't observed with that telescope before, you would expect to see a similar distribution and type of galaxies in that field as in the other field. It's no different than making that sort of assumption. On Lyle's model, we would see the same things at farther distances, just like we would see the same things in different fields of the sky at the same distance. So, I mean, I don't know if you want to add something else there, but
no, you did it. Ben, clearly you've studied this topic extensively. I love it. Tanya Brown is wondering, does relativity mean millions of years could be passing in space? If we see the light instantly, why doesn't the image jump?
Well, the image is of a real thing, so the image would only jump if the real thing jumped. I hope that answers your question. As for does relativity mean millions of years could be passing in space? I don't think so. Well, on Lyle's model, right? On other young Earth models, it would mean that, like
right, like with Humphrey's gravitational time dilation would be. So would that model essentially be saying, since God stretched out the heavens and you had that deep gravitational time well, with time essentially stopped, with Earth at the bottom, kind of like throwing a bowling ball into the middle of a trampoline, it sinks right to the bottom. Then you got the stars and the galaxies higher up, experiencing less time dilation. So when God stretches out the heavens, would Dr. Humphreys basically then say that Earth could be literally 6,000 years, 6 24-hour days, but since stars and galaxies came out first and the Earth last, so the Earth experienced the most time dilation, stars and galaxies in deep space could be billions of years old, essentially. But the Earth still 6,000.
Right, by their own clocks.
Right.
So I guess relativity implies relative time, which I talked about in the presentation early on, that there's no absolute time. So that means there's a clock at each point in space, sort of, where time is passing according to that position in space, but not absolutely. And yes, that means time can pass at different speeds at different points in space. So I guess the answer to the first question is yes. But it doesn't entail it. It means that it could be the case.
Right.
Yeah. And yeah, that's what, so Humphreys has at least 3 different models that he worked on. And the one you described is his more recent model, which uses gravitational time dilation, which slows the passage of time. And so he suggested that the Earth is in this huge gravity well that slowed the passage of time a lot for us. But the distant stars, they didn't experience as much slowing of the time. And so they could be, billions of years old by their own clock. So I guess the answer to your question is yes, sort of, depending on your model.
That's why, because I used to argue for gravitational time dilation going back years ago. I used to argue for that in debates too. But in examining the ASC model, hearing you explain it, Dr. Hartnett, and having Dr. Jason Lyle on specifically to deal with it, I feel like it's a simpler model in many ways. I mean, we're just saying that distant starlight arrives instantaneously because the one-way speed of light is a matter of convention, not measurement. And that's a solution fully consistent, as you've said, with the physics of Einstein and scripture. And so we see the most distant light from the most distant galaxies in real time. Mm-hmm. And Adam and Eve would have seen that in real time as well. So it's a very simple explanation, and it's incredible. And a lot of critics just can't wrap their minds around it because it does seem a little counterintuitive. Dr. Lyle's pointed that out, but it is logically, scripturally, and scientifically consistent. But I did want to get your thoughts on this from, where is he? Mr. Anderson.
Mr. Anderson. Welcome back. We missed you.
We've got Agent Smith himself here trying to take Neo, the chosen one, Ben Kissling, on distant starlight. And so he's wondering, he has a couple. So we'll start with this one. If the observer is not on Earth, will the light from a distant object still travel instantaneously to that person?
Okay, that's a great question, and I actually didn't quite understand this for a while. So it depends on your synchrony convention. I know I'm going to sound like a broken record here, but so technically, the convention that would be used would be the observer and the distant point wherever the light is being emitted from. Okay, so that gives you an orientation as well. And so on the ASC model, it is more complicated because you would have to use technically a different convention for every distant object. That means if the observer is not on Earth, he can just use the ASC from his position, and it would work the same way from his position. But I suspect that the intuition behind this question is a failure to understand something that I tried to emphasize in the presentation a lot, and that is that the coordinate system you use does not affect the physical nature of light. That's why I spent a lot of time trying to explain how time being the fourth dimension and a different coordinate, just like the spatial coordinates, is not going to affect any physical reality. So light is going to be unchanged by whatever coordinate system you're using. Okay. And I just recommend going back and listening to the video again, especially the latter half where I talk about four-dimensional space-time, to try and get your head around what it means for time to be a coordinate. It means it has nothing to say about the physical nature of light. It's literally you just choose it, right? And it has consequences within that coordinate system after you make the stipulation. But it's not going to change how light travels. So the answer to his question is it depends on which coordinate system you want to use for that observer. You can use any coordinate system you want.
So if this observer is not on Earth, he's hanging out on Mars or Jupiter or something like that. Again, it just comes down to the method of choice for convention wise. It'll be instantaneously if you're using the ASC model.
Well, the convention.
The convention, right.
The ASC model would say, maybe that's what he's asking. The ASC model would include information from the Bible, which says on Earth time, so from the Earth's reference frame on day 4, light would reach Earth instantaneously. So maybe that's what he's asking. If on the ASC model, would light from a distant object still travel instantaneously to that person? I don't think so. But I'm not sure. That might be a good question to ask Lyle if he comes on again.
Is that because it's not an Earth-centered? Because the ASC model would affirm Earth's frame as the reference.
Right. So if you're going by the ASC model and talking about how light behaves in the same reference frame as the ASC model, but just being observed from a different location in space, okay, that's the key. Yes, it probably would be different because of something I did say this in the presentation. If you read Lyle's article from 2010 in the Answers Research Journal, he talks about something that I think would relate to this situation. And that is that the Einstein synchrony convention is dependent on velocity, but not position, which means that on the Einstein synchrony convention, if the person was on Earth or Mars, they would still see the same two events as being simultaneous, as long as they were moving at the same velocity as each other. But position-wise, it wouldn't matter at all. On the ASC, however, position does matter and velocity doesn't. So if they're in a different position, I'm assuming they would disagree on the simultaneity of the same two events. So I think the answer is no to your question. But I'm not an expert, so that requires. I would want to ask an expert before I'm super confident in that.
Hey, we're going to have to do a follow-up show with Dr. Lyle, maybe sometime in the next few months, and have you as one of our co-hosts to ask some of these questions to him as well.
That'd be
Mr.
great.
Anderson, wouldn't that be cool? Yeah, I'm going to try and set that up. You, Sam, and myself, and we can dig a little deeper into some of these hyper-specific questions. Mr. Anderson's wondering, isn't Lyle's theory inconsistent with the observations of LIGO? How could we accurately predict the location of a black hole merger unless either one or the other of gravity waves or light are Lorentz?
Okay, so LIGO is the thing that detected gravity waves. How can we accurately? Yeah, I'm gonna have trouble answering this question again because I'm not an expert. So I might have to just not answer this because I don't know. um, yeah, this. I know that Lyle has written things on gravity waves. This is common attempt to refute his position. My suspicion is that you could predict it on the ASC. It's just the math would be different. And people are not fully understanding how the math would be different. I suspect this is a similar issue that Dennis has, is he's using a bunch of assumptions and equations and stuff from the ESC that assume the ESC, and then trying to shoehorn the ASC in after it when you have to go back farther and reformulate all these equations according to a different simultaneity convention. But I don't think it. Lyle's position is that there is no empirical difference between the ESC and the ASC as long as you do the math correctly. And so there's no way to distinguish between the two different conventions. And as far as we know, I know LIGO is in the Earth's reference frame, right? So is detecting or maybe a satellite or something. So I suspect that Lyle could account for this. Just he would have to do the math differently. And he's just one guy, man. He's going up against the entire academic establishment. So they're going to be able to put out a bunch of papers and everything. And he just can't do that by himself. So, but that may be a better question for him.
Well, and I'm just brainstorming here because I just looked it up right now. It'll be a good question for Dr. Lyle in the future. If LIGO cannot measure the one-way speed of light, then it wouldn't do anything to undermine ASC. If their measurements would be entirely consistent with any synchrony convention, including ASC.
Yeah, I think that's the correct answer, but I'm not sure if this is something that where Lyle's model would make a prediction that's different. Okay. I just don't know it well enough to definitively say one way or the other. So,
yeah, because if LIGO itself is assuming a synchrony convention using the Einstein synchrony convention by assumption, not by measurement, and so okay.
Right. So the big prediction from Einstein was that gravity would travel at the speed of light. And that was a big difference between Einstein's theory and others. And so the detection of gravity waves is supposed to be a confirmation of relativity theory because of that.
Okay, good stuff. Frank, I'm just reiterating this because he's emphasizing a point that you made earlier in your slide about the predictions. He says, Ben, good point that Lyle's ASC model made predictions that were confirmed. The James Webb Space Telescope found galaxies at higher redshifts that were fully formed with heavy elements in them. I still think it's pretty awesome, too, that Dr. Lyle made these predictions, what we should expect to find if the universe is young and specially created, and also predicted how critics and Big Bang proponents would respond in light of the data that contradicts their position. So as young Earth creationists, we oftentimes know how the critics think, don't we, Ben?
Yeah, that's a common experience that I have, is that being in the minority position, we pretty much have to learn the majority position. But the majority position does not have to learn our position.
You're right.
and so they think they can criticize it without knowing what it is, which.
Well, I guess people are going to see that with Creaky Blinder. A lot of times he just hand waves away what we're saying.
He says, I don't read creation literature.
Right. He's like, why would I? This is a creationist. They're biased. They start from the Bible. So now he feels like he doesn't have to address the science. Tanya's wondering if the ASC model is correct, does that mean that either the universe is young or new stars and galaxies are forming?
It does mean the universe is young. It doesn't say anything particular about whether new stars and galaxies are forming. That would be determined by observation, which we have not ever observed a new star forming or a galaxy forming. That's not happened. And Lyle, actually, I've heard him argue that new stars cannot form, that there are physical reasons, meaning physics reasons, why stars would not be expected to form spontaneously. But the thing about that, people say, well, how could we possibly observe a new star forming? We observe them in the process of formation, they say. But of course, we've not observed a new star form. That's extremely rare. Well, supernovas are not rare. We've observed stars blowing up. So you look in the sky and you see a star one night. The next night you look up in the same location and there's an explosion. The star exploded. It happened. We saw it. We observed it. Okay. We've never seen a star form like that, where at point A we saw a gas cloud and at point B we saw a star. That's never been observed. Now, that doesn't have anything to do with the ASC model. That has to do with other physics and other observations. So I guess the answer to her question is no, the ASC model does not mean that new stars and galaxies are forming. It does mean the universe is young.
How does ASC interpret supernova events? You mentioned supernovas, especially those supposedly billions of light years away.
It means that the supernovas occurred when we observed them. Or, if we observe them, or the supernova remnants that we see are occurring as we observe them. That's all it means.
So if we see the remnants or after effects of a supernova from a couple billion light years away, the ASC model would basically say that star just exploded and we're seeing the remnants in real time.
Yeah. And actually, supernova remnants is an argument that has been made to support a young universe.
Right.
Briefly, in a section, in some section of this was done several decades ago when it was first noticed. In a section of the sky, they took a section of the sky, right, and they counted how many supernova remnants they had observed. And then they came up with a rate at which we were observing supernovas to occur. And I think the numbers were, on an old Earth model, we'd expect something like, I think it was 1,200 supernova remnants in that little section of sky. On the young Earth model, we'd expect around 100 or something, and there were 200 observed. So it was a little bit more than the young Earth model expected, but a whole lot less, an order of magnitude off from the old Earth model.
Right.
So this was also used against Russell Humphrey's model, because Russell Humphrey's model posits an old universe but a young Earth. And so this is actually evidence for a young universe.
That brings to mind a question that I've always had and wondered, because we know Dr. Russell Humphreys has made predictions on the magnetic fields of planets further out in our solar system, indicating that they're young, and those predictions came back true. So how does that work with the gravitational time dilation model if the magnetic fields of those outer planets appear young based on his predictions? If that question makes sense.
Yeah. So the planets in our solar system would not be significantly different than Earth's time.
Okay.
Earth's clock, I believe, on Humphreys' model.
Because our solar system basically experienced less time dilation than other solar systems and galaxies billions of light years away.
Yeah, and we've only measured the planetary magnetic fields of planets in our solar system.
Right.
So that's the predictions that he made about Uranus and Neptune. And yeah, Humphreys is a great creation scientist, one of the greatest.
Right. Yeah. Big time.
Yeah. So I definitely don't denigrate him at all. But I do think he was wrong about this particular issue. So, but he
Even
made
though
a
his
lot.
model does have some explanatory power. I do like it. I like both models. I just lean ASC because it's simpler and it's without any real good criticisms, I find. But what if a critic were to say, okay, Ben, the James Webb Space Telescope refutes the ASC model because we're observing the early universe. So the further you go back, these are galaxies that are earlier in history, even possibly according to the young Earth creation model. They're just maybe earlier by, well, no, we would say they're all specially created. But then time has moved on, obviously, for 6,000 years. And so, how would ASC interpret those findings? What would be the best way to refute that criticism, Ben?
The criticism that we're seeing back in time when we look farther out.
Right. So, how could we be seeing that in real time if we're looking back in time,
Well, it's
basically?
just that we're not looking back in time.
So
That's
it's
yeah,
assumption.
that's a timing convention that depends on the timing convention that you use. So, yeah, um, you know, I think that mainstream or old Earth physicists and scientists in general tend to take what they view as the best theory and assume that it's true. And then over time, they just end up believing that it's true in the absolute sense or the correspondence sense of truth. And so they tend to forget all the assumptions that went into it that could be changed if the data was different. And in these kinds of cases where we have the James Webb Space Telescope giving us new data, the data is coming in and it's different than they expected. And so they're having trouble getting their heads around that. But I think they assume that the Einstein synchrony convention is true because it is mathematically simpler and it leads to a simpler cosmology. Even Lyell admits that, right? If you use the ESC, it makes the math for cosmologies or cosmological models simpler. He says there's some situations where the ASC makes for simpler math, but most of the time the ESC is simpler. And he says flat out he uses the ESC quite often to do calculations. So the key point is that neither one is true or false. They're just mathematical tools, and we pick which one we use based on the situation. But a lot of scientists get it in their heads that the model that they use every day, that they're most familiar with, that makes the most sense to them, that is mathematically simpler, must be the true one. Okay, and I don't think that's a good way of thinking about scientific theories, but that's kind of another topic.
Well, no, I think that's good. And I think in many ways you just answered Tanya's follow-up question. And it's a question, it's something I've wondered as well, because just like you said, and Dr. Lyle have said, both can be true. It just matters what convention you're choosing. So she's wondering, so even though it's a convention, can one of them actually be true and the other is false? The light is either getting here instantaneously or it's taking a lot of time. Like, can one be true over the other? Objectively, maybe, or ontologically?
Not if relativity theory is true.
Mm-hmm.
If relativity theory is the final true theory of how everything works, which I doubt, but if it were true, then none of these conventions are true or false. It's literally just a coordinate in a coordinate system that we use to do math and figure stuff out. It's not a feature of physical reality. Now, I suspect relativity is not the final solution or the final physical theory. We know that relativity conflicts in certain cases with quantum mechanics, which is the other greatest theory of all time. We have two physical theories that are the best physical theories ever discovered, and they're both very accurate when in the predictions that they make. but they're deeply incompatible with each other. So we actually have really good reason to believe that there's new physics that we haven't discovered yet. And I have just a kind of a musing, a daydream that maybe if you look at Genesis 1, what does it say? Well, it says the earth was formless and void, and darkness was on the surface of the deep. And God said, let there be light. And there was evening and there was morning the first day. And it looks for all the world to me like the earth exists. God created the earth at t equals 0. When time equals 0, God instantaneously creates the earth. And then he creates time, and then time, or rather, then he creates light, and then and he said, let there be light. And when God creates light, it looks to me like time starts. Mm-hmm. So I have this fancy that maybe time is dependent on the existence of light, that light somehow generates time. And maybe there's a way to try and look for new physics using that idea, but I'm not going to be doing it. I'm too old to start a new physics career. Yeah. There's a saying like you have to be if you don't make your contribution in physics by age 30, it's never going to happen because it requires some really heavy duty brain power. So we need some young hotshot young Earth creationist physicists out there who are willing to follow the Bible where it leads.
Some young up and coming young Earth creationists, Einsteins.
Yep.
Wouldn't it be nice if we could live to the ages of our biblical patriarchs? If we could live to 500, 600, 700, imagine how many more research projects and how many more subjects we could become experts at. The time really is limited, Ben, that's for sure.
Yeah, you got to wonder how smart those guys ended up being.
Right. Wouldn't you just love to sit there and have a casual conversation with Noah or Shem or Ham or any of these biblical patriarchs? So, okay. There's a couple objections here that would be curious. Well, here's just a basic question. Where was the prediction made that there would be no galaxies beyond that specific galaxy, a certain galaxy 14, Z14?
I already answered this, but I can I can show the article if I can find it for you. Oh, well, that's the wrong website. Whoops.
There was, as you're pulling that up, there was another question of someone was asking where we could find the video we did with Dr. Jason Lisle. I'll grab it and post it in the live chat as Ben covers this question. Just let me know when you'd like me to screen share, Ben.
Yeah, 1 second. See if I can find this here. I can never remember the name of the article, so I always have to go to this other article.
Well, there's quite a few. Like, you can take a real deep dive. As I showed earlier, if you go to Biblical Science Institute, so far there's 5 parts in Dr. Lisle's response to Phillip Dennis's errors in physics, ASC, and philosophy. If you go to the ARJ, the Answers Research Journal, Dr. Jason Lisle put out a very comprehensive technical response to Luke Barnes. My quick question to you, Ben, has Luke published in the ARJ. He published a response to Dr. Lisle critiquing him. Then Dr. Lisle responded very comprehensively to Luke Barnes. Has Luke Barnes then responded to that response?
Not that I know of, and I looked on his website and I wasn't able to find anything on Lisle or the ASC. But the thing to remember is that Barnes's article was really critiquing a different claim that Lisle made. It's not really the ASC.
It was the James Webb Space Telescope prediction?
No. So part of the Big Bang model is that I have those sites, by the way.
Okay, yeah. Actually, before we move on, if you want to pull those up, we can answer the
I got them.
Original question. Okay, I'll screen share.
Okay, so whoa, what just happened here? Okay, so this is the original one, and you'll see the date is January 21st, 2022. This is before the results came out. And you'll see he said an update here. This article makes predictions about what the James Webb Space Telescope would detect. We now have the results. And then he links to the article that he wrote after the results came out, which is this one called Creation Cosmology Confirmed. So you've got the James Webb Space Telescope, where he made the original predictions, and then this one where he talks about their fulfillment. So that's that. That's all on biblicalscienceinstitute.com. And I can confirm that he did, in fact, publish them at the time he says, because I read it at the time. And even in the 2010...
so they're not retrodictions. They're legit future testable predictions.
Yes. So in his 2010 article in the ARJ, am I still sharing my screen?
Yes, I can put it up again. There we go.
Okay, so on the Answers Research Journal, just look up anisotropic synchrony convention, and I quoted several times from this article in the presentation. So this one, this was published in the ARJ. And so if you read this whole article, he explains near the end how you can get testable predictions out of this article, out of this model. And this is in 2010. So it's quite a ways before his articles on the website. Where are we looking at here? So he explains how blah, 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 blah. Synchrony convention, biblical basis, the SC model, right? So here's where he says, the convention is just a convention. It is not a model. It does not make testable predictions. Okay. However, I have made an argument that the Bible uses the ASC, and this claim is in principle falsifiable. Though, of course, I have argued that it is true. We can construct a cosmology that does make testable predictions. Okay. So in this section, he explains how he would make observational predictions based on the ASC model, and I suggest you go read that. Okay, that's all I had there.
That's good. No, that's good.
Okay, now what were we talking about before that?
Several different things at once. So Luke Barnes, his response was not.
Yeah. So on the Big Bang model, basically there's like about a century ago, they observed that light from distant stars is red-shifted. Okay, and what that means is we can shine a light, basically in a simplistic terms, we can shine a light through hydrogen gas and get a spectrum out of that light, meaning that the hydrogen absorbs some frequencies of light and reflects others. And it's different for different types of elements. So you can actually tell what element you're looking at by shining light on it and getting the spectrum that's associated with that element. Well, we can see the same kind of spectrum. I think it's through a lens, actually, not reflected, but we can see the same kind of spectrum in distant starlight. And if it shows the same pattern as something like hydrogen, we can say, well, there must be hydrogen in that distant star. Okay, and we do see that. We see the hydrogen spectrum, we see the helium spectrum, but they're actually slightly off from the frequencies of light or the wavelengths of light where they should be, and they're a little lower frequency, longer wavelength. And if you look on your visible spectrum of light, the highest one is like blue or indigo, and the lower wavelength is red. And so because it's a lower wavelength than it should be in these spectrums, we say it's red shifted. Okay, it means it has a lower frequency, longer wavelength. And so the question is, why is that happening from distant stars? And so when they noticed this, they also noticed something that they called the Hubble law, which is a correlation between how much the light spectrum is redshifted and the distance of how far away the stars are. Okay, so the farther away the star, the more its spectrum seems to be redshifted. And so Hubble and I can't remember who exactly proposed this. They proposed an explanation for this. Their explanation was that space itself is expanding. Okay, and what this does is it stretches out the wavelengths of the light, which makes the wavelengths longer, right? And so that's an explanation for the redshift. And this became the Big Bang model, where they assume they think that the redshift is evidence that space is expanding. And so if it's expanding, well, it must have come from singularity sometime in the past. And this is where they do the whole Big Bang model based on this. But Lyell has suggested an alternative explanation for the redshift. And his explanation is no, space might not be expanding. It might actually just be the case that the galaxies are moving away from each other in a non-expanding space. This would also cause a redshift in the spectrum. Okay, and it seems to be a more intuitive suggestion.
If I could stop you there, because I'm trying to understand it as well. So technically, the typical understanding is that space, kind of like a balloon, if you only inflate it a little bit, put a bunch of dots on there, and then start inflating it, then the balloon is expanding. So the space is expanding. Those dots are getting further apart, but it's the space in between them. But Lyell is saying it could actually be the galaxies, which could be analogous to those dots that are moving themselves and not the space expanding.
Yeah, the balloon would be staying the same size, but the dots are moving away from each other on the surface of the balloon. So literally, it's like me running or moving on the surface of the Earth. It's just a normal movement of the galaxies away from each other.
Without the space itself expanding.
Right.
Okay.
Yeah. So he thinks that's a good alternative model for the redshift. And he says that before James Webb, we didn't have a real good way to discriminate between the models because it required observations from higher redshifts. And when the James Webb results came out, Lyell looked at that and he said, I think we've got some evidence for this alternative model of how to explain the redshift. And so he wrote an article on that. And Barnes's article was in response to that article.
Okay.
So Barnes wasn't necessarily responding to the ASC. And then Lyell made another response to Barnes's article. I think Barnes suggested some model, and Lyell said, well, this model is ruled out because of this evidence, and that's why I didn't consider it. So Barnes accused him of not considering this alternative model, and Lyell said, well, I didn't consider it because it's ruled out for this reason.
Andrew says those two models are observationally indistinguishable. Lyell's model is essentially just a coordinate transformation. So he's saying, yeah,
that's not my understanding of this issue.
It does seem like these models would differentiate, because I mean, those are two fairly large different starting points in those explanations, where rather than the space expanding, it's actually just the galaxies expanding themselves.
Unless Andrew is saying that Lyell is wrong. No, so Lyell says they can be differentiated on the basis of, and he puts some graphs in his articles on this, showing what the difference would be. And he says that expanding space would cause a magnification effect that is increasingly noticeable past a certain redshift, and I don't remember what it is. So he says that on the Big Bang model of expanding space, we should see a magnification at greater redshifts that we wouldn't see on this alternative model, which we call the Doppler model. And he thinks that can be distinguished now with the evidence from James Webb, that we were not seeing this magnification effect. Now, you could say, Cosmology, a bunch of accumulated. Yeah. So, I mean, you could say, right, that, well, those galaxies past that certain redshift, they're just bigger. So in that sense, right, you could say that the two models can both accommodate the data. But that seems like a strange ad hoc assumption. Why would we assume that galaxies farther out are just all, like, on average bigger?
Well, just like most competing models, aren't there many observations or data points that both models can account for? And then Dr. Lyle, like the one you mentioned about the magnification observation, I guess, could help differentiate between those two explanations. So I'm sure there are many observations within the models that both can account for, but then maybe a couple that can help differentiate, which would favor Jason Lyle's model.
Yeah, and I mean, this gets into a philosophy of science issue. So that's kind of my main interest now, is philosophy of science. So I don't want to get too far off, but basically, I don't think that falsification is really possible in real life, because most scientists are clever enough to adjust the model to most data that comes in.
That's a good point.
Which is what
There's
they're doing.
always a rescue device that can be employed.
And so really the only way to differentiate between models is subjective preference about how much ad hoc rescue devices you're willing to accept, basically. So
who's got the we could frame debates like this, you know, who's got the most rescue devices or the most far-fetched. So although both models, any model can really invoke a rescue device or a rescue mechanism, how far-fetched is it? You know, who's got the more far-fetched rescue mechanism?
Yeah, and that means you've got to make some decisions about what you prefer out of models.
That's true. Well, and with the creation model, we start with the assumption that miracles are possible, that God kickstarted time, space, and matter, that there was a global flood. So us as Christians, interpreting the Bible literally, we are going to have a preference to the creation model because we're not limited to only naturalistic explanations for all these different data points. Whereas the evolutionist or the naturalist is rejecting any miracles, any supernatural aspects to the universe. They reject a global flood. So right there, some pretty major differences in terms of what we're going to prefer. Is that right, Ben?
There are differences. I would phrase it as we think that information in the Bible, historical information from the Bible, counts as evidence. That's how I would say it.
That's good.
And other views don't, right? So we would say we think that the global flood was observed and recorded in Genesis, that special creation over 6 24-hour days was observed and recorded in Genesis 1, and that that counts as data, just like any other observation. And therefore, our scientific models have to account for all the data, and if they don't, they're not good ones. Whereas if you exclude data, historical data from the Bible, you can make models based on only the other data, and you can say, well, our models explain all the data, but you just have a different data set than we do. We accept more data than you do, essentially. So, and we have our reasons for doing that, some of which may be religiously motivated, at least partially. But I don't think it's an irrational position to say that a historical document as credible as the Bible should be taken seriously when it says there was a global flood a certain number of years ago. I think that's a perfectly reasonable thing to do, and I think it means that we should be trying to make models that explain that and accommodate it.
Ben, you've done an excellent job on this topic. We've gone nearly 2.5 hours on just the distant Starlight issue. You've done a great job debating a lot of these comments and critics. And so let's get in one more. And as you answer this one, I'm going to go fill up my water real quick. And then we're going to jump into a response, in many ways, a preliminary response to some of Creaky Blinder and his point. So, okay, here's the last question we'll deal with currently. And I understand there's a lot of interest and it's complicated in many ways, the distant Starlight issue. And so we can do follow-ups as well in the future, maybe more Q&As and so on. So Tanya Brown.
I would love to talk to Lyle and just pick his brain.
Yeah.
Have like awesome. a month to read up on it again and come up with some really good questions. And because there's some things I don't understand about ASC that I'd like to ask. But the answer to this question is, I think, yes. So.
Well, I guess that was a quick answer. Let's sneak one more in that might.
If it's really a collision, right?
Right.
If it's not just, one galaxy that's next to itself or has a different structure than other galaxies.
I think
the assumption that it's a collision assumes that they've been hitting each other for a long time. And I'm not sure that's been actually observed. That may have been assumed from an old Earth model, but
yeah, like applied to plate tectonics. Plates have been moving around and slowly colliding with each other over millions and millions of years. Applied to astronomy. Andrew Cummings says this, so perhaps address this objection. I'll fill up my water real quick and we'll get into good old Creaky Blinder.
That's just not my understanding of the data. So I would have to see papers that you've read that say that, because in the articles that I saw Lyle writing, he had several references to papers. A lot of them were pre-publication, but people refer to those all the time nowadays. So my understanding is that's not correct, but I don't know. I could be wrong. So I'd like to see where you're getting your information, and I can look at it. Let me see if I can find.
Okay, back just in time. Are you looking to screen share something?
No, okay. I don't know if I'm going to find this. We can move on.
This was good. It's very rewatchable, especially your presentation. And I'm going through all the questions and comments I had saved. And you did a good job addressing all of the points and objections that came in. Yeah, there you go. You get an A+. As I said earlier, I think you made your dad proud. This was above and beyond what you did last month in last month's presentation. Okay, so let's jump into Creaky Blinder, and I've got everything set and ready to go. The first roughly 2.5 minutes are, I'll give a point to Creaky for rhetoric. His videos are well edited, somewhat funny at times, and fast paced. But I do think he's 99% rhetoric, 1% evidence. We'll give him the 1%. We're going to engage that. So I'm going to skip the first couple minutes of just introduction where he's not really engaging any of our points. And I know you got some points that you want to go over too, Ben. So I'll play the video. You just tell me when you want to stop. And then if you have like a mini presentation or a couple slides you want to go over, let me know as well. And we can do that contextually in the video. Just let me know when that time is right. To give the audience an overview, we did a video. We did a program maybe a couple programs ago responding to theistic evolutionist Redeem Zoomer. Is that his name? Redeem Zoomer? So we demolished him for a few hours, and Redeem Zoomer behind the scenes hired Creaky Blinder to respond. No, I'm just kidding. But he had to get an atheist evolutionist, I guess, to defend him. And so he did the response rather than Redeem Zoomer.
Oh, my mic was muted. Oops.
Yeah. Did you want to repeat what you were saying on mute?
Oh, I was just saying, young Earth creationists are conspiracy theorists.
Right. Yeah. That's
See,
sometimes that's all
Donny
they
has
got. Yeah.
prone to conspiracies.
Redeem Zoomer reached out, paid Creaky Blinder the big bucks. Please, defend my arguments for me or refute young Earth creation. So Creaky Blinder put out a video. Sam and I addressed that in a follow-up. We went through every single point he made. We went for a few hours. Creaky Blinder put out a response to that about a month ago. So we are going to engage some of that response. Now that we're all up to date, let's screen share. And Ben, you just let me know when you want to pause and say things.
Are we going to go through the whole video?
No, we'll go through some of the highlights because we'll probably want to get together in a month or so anyways, because Creaky Blinder, he's a busy man. He's a busy evolutionist. He's already put out another video. So we might want to just dedicate at some point in the future a whole program to addressing him if he presents anything worthwhile. He's, as people will see, kind of hand waves away some of the points, helium and zircons, for example. But yeah, and if you watch the whole video, Ben, you can make some points and say, later on, Creaky says this, or even give a bigger picture response as well. So here's Creaky Blinder. We'll go full screen. I'll hide this so it's not in the way. I'm going to stay off mute. So if there's an echo, let me know. And then actually, Ben, can you say something? I want to see if StreamYard fixed their echo problem.
What's up? I need a haircut. I just realized looking at this old picture of myself.
You got a haircut now, but not a haircut then? Because
actually back then I had quite a few hairs cut.
Oh, there we go. Yeah, not just one. So okay, it looks like they fixed the echo issue. I appreciate that, because before, when someone else would talk when we're screen shared, especially with audio on, for some reason there'd be an echo, weird echo with guests, but looks like I didn't hear no echo there. So
I tried to go on a StreamYard as a guest over Christmas break, and I was on my phone and it really messed up my audio. It was really terrible.
Oh yeah, I was all distorted and echoey as well.
Yeah, it sounded like a Darth Vader, except like a retarded Darth Vader.
A degenerated version that experienced some mutations and genetic entropy. Okay, so we're going to start it here, 248. Ben, let me know, because I know you've also written down some points that you want to address. So let me know when you want to pause, and let me know when you want me to screen share for you, or if there's certain points you want to address.
I won't need to screen share for this, but
okay. So we'll play it. We'll go through as much as we can. Let me know when you want to make some points, and we'll go from there. Okay, let's start now.
And Ben Kissling has a presentation, a comprehensive presentation that I'm really excited for, going over some of his favorite, if I'm not mistaken, 5 of his best pieces of evidence for young Earth creation.
Ooh, how exciting. Now, I'm genuinely curious if Ben's top 5 is going to be the Creation Science Greatest Hits album that we're all expecting. Yeah, you know the tracks, right? Slippery Helium featuring Zircon, Not Enough Salt in the Sea Blues, Dino Bones Just Got Collagen, Distant Light, Instant Journey, the ACS mix, and a bonus track, Radiometric Dating is just a suggestion.
Are those really the greatest hits, though, Ben? I'm not sure I've ever seen those 5 in combination other than your presentation. ASC mixed in with salt accumulation. I'm not sure those would be considered the greatest hits. What do you think?
I think some of them would be. Yeah, there's definitely top 10 lists I've seen with those in them. Usually the C one doesn't make it, but he probably figured I would put it in there because I used that argument. But
and then you use CPT as a whole, the entire model, the explanatory power, the prediction, so on and so forth.
Those are usually at least two different ones. I kind of I cheated and put them all together. So
yeah, one of your points was just CPT as a whole, just a massive topic, which is a powerful model. So it makes sense. It explains a lot.
Yeah. It included the magnetic field stuff that is usually a different thing, but
there's a lot of confirmed predictions mixed in to that model that the critics, to adequately deal with CPT, would have to deal with those predictions. He does attempt to deal with cold slabs, but okay, let's continue.
Title of the video: Young Earth creationists has no clue how science works.
I'm not sure why you're laughing at that, because it's very accurate.
So I guess we're going to see.
Why I'm laughing is because from my experience, and maybe you have the same experience, Ben, is over the years we've responded to a lot of critics. You can go on the website, standfortruthministries.com, click video section and scroll down to the bottom where it says refuting the critics. And I've got a section for all of your most popular and not so popular critics, those that have made any kind of worthwhile arguments. We've got Redeem Zoomer in there, William Lane Craig, Theistic Evolutionist, with your responses as well. And a lot of the critics just end up repeating the same talking points, or they don't seem like they're up to date on the evidence that we're using. They refuse to look at our literature on the topic. For example, I put out a video recently, and I've got it. I'll go to it later, where we have Dr. Andrew Snelling refute objections to the helium and zircons. So at this point, the ball is really in the court of the critics to address our counters to their objections or talking points that really have been addressed over and over again by young Earth creation scientists like Russell Humphreys, Andrew Snelling, and others. But that's why I'm laughing, because it's like, okay, well, here we go again, Ben. You know. Anyways, if you ever want to add anything, just let me know, brother. I just wanted to point that out. That's why I'm laughing.
How true that assertion is here today.
Well, bring it on then, God boy. I mean, 3 against 1 is hardly fair, but I'm not worried because I've got something far more powerful on my side than any god or gods. The truth, which is awesome, because all I have to do is look things up. And you 3, well, you've got to squint and stand on one leg and spin around just to produce anything that could even have a chance of being misunderstood as evidence. Oh yeah, I almost forgot. And you have to call every scientist ever a liar.
Point out
well, a couple points, and then Ben, let's give you your thoughts. Every scientist ever. Obviously, I've told Creaky a billion times not to exaggerate, but seriously, we could name hundreds to thousands of young Earth creationist scientists, intelligent design scientists, PhDs. We've had dozens and dozens of PhD scientists on this channel alone arguing in favor of creation and debunking or providing good arguments against evolution. So, obviously that's not true. A lot of that is banter and rhetoric, right? I mean, does he really have truth on his side, though? He claims that he's got truth on his side, but we can assert the same thing. We can claim the same thing. We actually need to examine the arguments and see who really does have the truth.
I mean, I may just do all these points at once, but I don't think he understands how science works, and I will be specific on that. I don't think he understands what evidence is, and I don't think he understands what knowledge is. So,
and I know you got some good points on that. So why don't you tell me, Ben, as we move into the video, tell me when you want to kind of just give one big rebuttal with all of that at once.
Yeah.
Is there a specific timestamp you want me to go to
I didn't record the timestamps, and I watched the whole video, so it may be that you're not going to play the sections that I was responding to, but if not, then I'll do it later. So,
okay, let's
keep going. Yeah,
let's give quick, brief responses right now, and then once we get through a good portion of it, I'll pause it and then put you on screen to give more of a kind of a bigger picture, comprehensive answer.
I mean, we don't, to my knowledge, we don't call scientists liars. We say we use data that's reported in the mainstream literature all the time. It's referenced in the creationist literature. We don't think they're lying about their data. We think they're, in some cases, some isolated cases that have to do with age questions, they're using assumptions that can be challenged. It's not about data. It's not about lying. It's about different interpretations of the same evidence. But, young earthers have said that exact thing many times before, and people like this just don't listen. So, I don't know.
That's a good point you make. I'm just going through.
I quoted Einstein in my presentation.
Right.
And I wasn't saying he's lying about that. I was saying he's correct about this. So I don't know.
Well, informed creationists like yourself, when we present, for example, when I present on ERVs or the science of Adam and Eve, chromosome 2 fusion, we are quoting and citing papers from the conventional literature, scientists that would disagree with us, but we understand the difference between the interpretation. For example, here's a few papers on functional endogenous retroviruses. Okay, we're looking at the data. We care about the data, but the interpretations made by the scientists writing those papers, we understand that a lot of those interpretations are up for debate. That's where critical thinking and good examination of the data comes into play. So we're not calling these scientists liars that are writing these papers, right? We may disagree with their overall conclusions and applications and interpretations of them, but that's what's up for debate, is the interpretation itself.
And I think this betrays a misunderstanding of what science is, because I think people like Creaky Blinders believe that the conclusions or interpretations of data are just the facts, right? And they're not.
That's a good point.
They're interpretations of data. But so when they see us disagreeing with those interpretations, they think that means we're calling the scientists liars, because they think those conclusions and interpretations are just facts that are being observed and reported. They're not. And if he had studied what science is at all, I think he would know that.
It's a great point. It's a great point, brother.
This comment, Andrew Cumming. There is no scientific support. What an assertion.
He's not wrong. There is, in fact, zero scientific support for young Earth creation. It's not a debatable point. It's the scientific consensus. The proofs you offer have been getting dismantled for decades. Just ask Kent Owen.
Not a doctor. Shh.
What you're saying is like a flat earther trying to assert that gravity isn't real. It's a hilarious claim, but it does not change reality.
Okay, let's stop it there for now. As we can see, gentlemen, Creaky Blinder is quite confident that there is no evidence for young Earth creation.
Well, it would seem that Donny and his pals think that my confidence is misplaced, but I stand by what I said. There is zero evidence for a young Earth, and your stuff has been debunked for decades. Also, I have no idea why you keep laughing. Is it like a nervous thing? Because you know that in your heart, I'm right and you were wrong, and you can't stand being corrected by somebody with face tattoos and stretched ears. Not everyone who loves science looks like a scientist. Sometimes they look like me.
It's true. Deep down inside, Ben, I am convinced that I'm related to banana plants, strawberries, and whales, that everything came from nothing, although they try to redefine nothing. And I find it interesting, then I want to hand it to you, that they'll assert that all of our arguments and proofs, you don't really prove anything in science, but our best pieces of evidence, they'll say, oh, they've been debunked over and over again. When in fact, it's actually the other side. I think we've demonstrated this in numerous programs. It's the other sides that are actually not addressing our best counterpoints. And that's why on this channel, we've had many of who I believe are the best young Earth creationist scientists out there. We just had Dr. Tim Clary, PhD geologist, on at the end of the year for a nearly 3-hour Q&A, where we allowed all the critics and skeptics in the live chat to offer up and present their best arguments and objections and challenges. And Dr. Clary did an excellent job addressing those, just like you, Ben, here tonight, for nearly 2 hours after your presentation addressed major challenges and criticisms to what you were saying. Anyways, Ben, what are your thoughts on that?
That was a great show with Clary, by the way. He's one of my favorite young Earth creationists.
Yeah, he's great.
But I was just thinking about the whole, you don't like me because I've got gauges in my ears or something. I'm like, man, if you knew the music that I used to listen, that I still listen to, that I grew up listening to, and the concerts that I went to, I was around people that looked like you all the time. I have no problem with that.
Yeah, you and Creaky Blinder could probably, we could probably get together with Creaky for a coffee and get along just fine, even though we disagree on worldview issues.
Yeah. Go to a concert. I have never seen Disturbed or Metallica. I'd love to see those guys. I think I went to a Static X concert back in the day, which those guys are crazy. This is kind of where at some point in the video, he gives a definition of evidence. And I have the feeling, this probably looked it up on a dictionary or something, but this is not the definition that philosophers use. The definition of evidence that philosophers use is anything which raises the likelihood of some proposition being true. That is a very low bar to meet. So when you, and philosophers understand this. So literally, like if I have a piece of evidence that, or something that raises the probability of some proposition being true by 1%, that still counts as evidence, even if it's the only piece of evidence for the proposition, which means your confidence in that proposition is 1 out of 100. Like, so you can be having a proposition that is only 1% likely to be true or something, but it still has evidence for it. That's what I mean when I say it's a really low bar to meet. So when you make this claim that there's no evidence for it, I don't think he knows what evidence is. And so I don't think he understands how massive of a claim he's making when he says there's none at all. Evidence can be really small. It's not a hard thing to find. I will freely admit there's evidence for an old Earth. And I'm assuming you would too, Donny, because you understand what evidence is.
Right.
When we look at two different competing models like this, we look at the weight of the total evidence and we decide which cumulative amount of evidence outweighs the other. But it's not, we're saying, well, there's zero evidence for the other side. I think people like him and Reasons to Believe does this same thing with young earthers. They say there's no scientific evidence of a young Earth.
Right.
I think they don't understand what evidence is.
Yeah.
They think that evidence means proof. And he even used the word proofs in that clip you played, as though proof is the same thing as evidence, but it's not. He thinks that evidences are proofs, and therefore if he admits that there's any evidence for our view, that would prove our view is true. And that's just not what evidence is, and that's not how evidence works. So, anyway.
I think you nailed it. It's the weight of evidence, right? That's why when I do debates, I do like to debate topics such as evolution on trial or Adam and Eve on trial, because there is going to be evidence for both sides, but we need to debate the weight of evidence, or which you said earlier was a good point, who's got more rescue devices or who's got the more far-fetched rescue devices, because any model, any position, regardless of your starting point, can invoke a rescue device. The question is the rescue device convincing? Now, what if he said, Ben, so are you saying there's evidence for the flat Earth? There's got to be models out there. So you
Sure.
said, right?
I can walk outside and see evidence for a flat Earth.
You know,
right? Earth looks flat. That's evidence, okay? Doesn't mean that it's the best model by a long shot.
Because then we debate that evidence, right? That'd be the follow-up. Like, okay, well, let's look at that evidence. Let's weigh the evidence. Flat Earth versus globe Earth.
Look at all other evidence that exists, and look at it all cumulatively, and evaluate the models according to what's called the theoretical virtues. That'll get into what science is, which I also don't think he understands. But
that's a good place for us
to move on.
Yeah, it's a good place for us to continue. Good points.
That whatever evidence we provide or offer has been dismantled for years and years, he says, and he even compares it to, well, first he uses argument from consensus, a fallacy that we can get into.
An argument from consensus is an argument that concludes a statement is true because lots of people believe it to be true. So I can see why you would say that, but like everything else you say, it's completely wrong. I don't believe that the Earth is 4.5 billion years old. I know it is. And the reason I know it is because that's what all the evidence shows us. You do know what evidence is, don't you, lads? You know, facts, information, or objects presented to support the truth or accuracy of a claim or statement. Now, the young Earth creationist claim, on the other hand, relies on taking genealogies literally. That's not science, mainly because the Bible isn't a science book. But Ben looks like he's ready to go. So let's hear some of this evidence then, Ben. But I will warn you, the second you mention the Bible, I will be dismissing that claim and moving on to the next one. Although that might make this a very short video. So we'll see where we end up.
And second,
hey, can we stop there? Yeah. So
that's a lot there I know you want to respond to, Ben. So yeah, go ahead, brother.
That's where he gave his definition of evidence, which sounds like it was taken off of dictionary.com or something. It's not the definition that professional philosophers use. Another issue he brought up here is that I hear a lot online, not from professional philosophers, is people who study knowledge are philosophers. And he says that I don't believe in the old earth, I know it. Okay. So he thinks that belief and knowledge are different things. Okay. And specifically that they're opposed things. But the professional philosophical technical definition of knowledge, as anyone who studies this would know, is justified true belief. So he's saying, I don't believe it, but I know it. Part of the definition of knowledge is a belief that you have. Knowledge is a special kind of belief. So by denying that he has a belief, but he does have knowledge, he lets us know that he doesn't know what knowledge is or how it's defined by the professionals who study this that are called philosophers. And he claims to know things because he goes to the professional literature and reads it. Well, I would recommend he go and read the professional literature on what knowledge is. And he would find that it's defined as justified true belief. And that means knowledge is a kind of belief. It means if you have knowledge, you have a belief by definition. So that was really frustrating to me. He says a little bit more about science there, but we can move on if you have more. That was one of my major points.
Well, those are really good points. He scoffs at the genealogies or the way we take scripture, interpreting it literally, taking it as history. But as we've done and said many times in the past, I mean, they can scoff all they want, but we've pointed out that, okay, we can test the claims in Genesis. God creates two people, Adam and Eve, separate and independent from any other form of life, including chimpanzees and banana plants. And we can test those claims. Maybe they're wrong. Maybe the scientific data is just going to completely overturn or contradict those claims. But when we actually test the claims of Genesis and the Bible as a whole to modern scientific data, they line up nicely. Right? I mean, we've looked at mitochondrial DNA that points back to a single female ancestor of all people on the planet. We've looked at the Y chromosome, which is incredibly different to the chimpanzee Y chromosome. And all male Y chromosomes on the planet go back to a single male Y chromosomal ancestor just 4,500 years ago, based on mutation rates and low genetic diversity. This response is not to go through all that data. My point is very simple, that good science affirms good scripture. So, you know, he can scoff at us starting with the Bible or testing the Bible's claims about human origins and the history of the universe in general. But he has to contend with the reality that the modern good science actually complements what scripture's teaching quite nicely.
He even compares it to flat Earth and their denial of gravity.
Well, that's not quite accurate. The reason I compare young Earth creationism to flat Earth is because they're both really stupid things to believe. And why are they stupid? Because neither are supported by any form of evidence.
But remind me, gentlemen, isn't that something, I mean,
what are your thoughts on that, Ben? Is young Earth creation and flat Earth, is it accurate to equate them or compare them? As he said, both are very stupid ideas to believe, Ben.
That's actually how my conversation with Luke Barnes started on Facebook.
Did he compare young Earth creation to flat Earth?
He did. I think my first comment was on I think J. Werner Wallace's Facebook page, and he posted this article by Barnes to premierchristianity.com about why he is not a young earther anymore. Apparently Barnes grew up as a young earther. And I posted something about, and I said, well, give us equal access, stop discriminating against young earth creationism, give us equal access to public funding and government grants for research, and then give us 20 years with equal treatment regarding public funding for research, and see what happens then. And Barnes came on and he said, why should we give the same consideration to flat earthers? Implicitly saying that we should discriminate against flat earthers because their view is not a legitimate view. And that's the reason we should also discriminate against young earthers.
Right.
And I immediately said, in response to that, did any flat earthers predict the results of the James Webb Space Telescope?
Right. What testable and falsifiable predictions are flat earthers making?
And then Barnes spent most of the rest of the conversation denying that Jason Lyle had correctly predicted the results of the James Webb Space Telescope, which kind of floored me. And I was like, I don't understand how you're justifying that because we have the predictions. I still don't understand why he...
And Luke Barnes is a physicist, right? He should know better. Is he an astrophysicist, Luke Barnes, or a cosmologist?
Yeah, he is. Yeah. I would like to see him debate Lyle at some point. I doubt that'll happen, but
that would be a great debate. That's a debate that needs to happen.
Yeah.
That's a good point.
I mean, there is no comparison between young Earth creationism and flat Earth theory.
Flat Earth doesn't even have a model. They don't make testable and falsifiable predictions. They can't provide a map.
When they do, it disconfirms the model. You've seen all those videos of flat earthers going to the Arctic Circle or something, you know?
Yeah. Will Duffy led that expedition. We've had him on several times, one specifically to discuss the 24-hour sun in Antarctica that should not be there if the Earth really is flat, and yet it's there, and it convinced at least one major proponent of flat earthism to give it up and go to the globe model. So there's a falsification of the flat earth because really there's no way to explain that. And many flat earthers for years and years, Ben, were arguing that, yeah, if we were to ever go to Antarctica, there would not be a 24-hour sun. And so they were that confident. They go there and lo and behold, 24-hour sun. Oops.
Yeah,
there's nothing like that for the young Earth creation position.
I mean, it's just like the last time I came on that I did the 5 evidences, and I think every single one of them had confirmed testable predictions, if I remember right.
Yeah.
So I don't think they're in the same league. But anyway,
I can't even think of a single. I'm not saying they don't exist, but I can't think of a single PhD scientist who advocates or puts out any kind of research articles or research papers that's flat earth. But we could sit here all day and talk about PhD research scientists that are young earth creation in every single field, from biology to nuclear physics to genetics to astronomy, geology, every single field.
Yeah, for sure. And I like to tell people about the Creation Research Society because they have 600 voting members, which requires a graduate degree in a relevant field. I suspect there are at least in the low thousands worldwide PhDs who are young Earth. It might be more than that.
Many well-respected, well-credentialed, well-published PhDs as well. Okay, here we go.
You can observe through experimentation. It's testable. It's repeatable. Evolution
is the same. Yeah, we know. You know what else is testable and repeatable though? Microevolution. We can observe it happening in the lab right now with bacteria and fruit flies. We can also observe natural selection happening in real time in populations, just like the finches on the Galapagos Islands. That's observable science as well.
Ben, just let me know when you...
Microevolutionary variations in the biological world. Bacteria, fruit flies, finches. Are those the types of changes, Ben, that are going to take bacteria-like organisms to biologists, goo to you, fish to fishermen, germs to geniuses? Are these adaptations, these micro changes, do they equate large-scale evolution?
No, because they don't create information. The micro-macro distinction is really outdated. Creationists did used to use that distinction.
I'm not a big fan of that either. Yeah. Well, because then evolutionists just play games anyways. They say, well, the definition of macroevolution is change at or above the species level. And we agree with new species, so I like to avoid the word macro versus micro as well.
Yeah. The real issue with evolutionary theory is genetic information. Where does it come from? And he mentioned natural selection and the Darwin's finches. I mean, there's been lots of work done on Darwin's finches. There's a couple who spent decades of their professional lives documenting changes in finch beak size of the Galapagos finches. And what this research showed is that there's no net evolution over time. The finch beak sizes vary back and forth based on wet versus dry seasons. When there's a dry season and the birds need bigger, stronger beaks to break open the harder, drier nuts, they quickly get bigger beaks, much faster than evolutionary theory would predict. And a lot of creationists think now that there's an awful lot of these types of changes that are not, can you still hear me?
Yes. Yeah.
That are not being caused by natural selection at all. They're being caused by epigenetic mechanisms that sense the environment and cause changes in response to the environment. It's a designed change. And when the season is wet, the beaks get smaller again because they just don't need the big beaks anymore. And this has been observed and published on for decades. Natural selection today is now known not to be very powerful at all. In many cases, like in these sort of minor situations, it's overwhelmed by genetic drift. And you only get natural selection actually working when it's a massive selective coefficient, which means things like it's going to cause you to die if you have it, which means that'll be selected out. Or there just aren't that many good examples of natural selection being shown to actually work in preference to other possible ways of accounting for the change. So I think a lot of evolutionists are backing away from natural selection as a major driver of evolutionary change, and that's for good reason. That's from data and publications in the mainstream literature. So he's just really out of date with some of this stuff.
It's just basic morphological change, shifts in morphology, larger beak sizes to smaller beak sizes, depending on the seasons, the environment. We understand environment can dictate morphology. So there's a difference between true anatomical novelty, an increase in information or phenotypic complexity, and shifts in morphology, largely due to epigenetic means and environment. You nailed it. Natural selection is limited, very limited. Can't see. And obviously, we're not given a mind to selection. It just means differential reproduction, who's reproducing the most. So if you have a mutation that's big enough, sure, that rare large mutation big enough for selection to see, that individual won't be able to pass on their genes. In the wild, picture the random zebra that gets a large mutation. Not these slightly deleterious mutations that are not big enough for selection to see, but a large mutation that gives it a shorter leg, one leg shorter than the other. Well, that zebra will probably be dinner for the lion. That zebra is not going to propagate and pass on its genes by having kids. Okay, so selection removes that mutant from the equation. But that doesn't do anything to stop the relentless influx of slightly deleterious, low impact mutations accumulating. But point is, I think you nailed it, that these changes are not explaining true anatomical novelty. There's a lot of morphological adaptability built into the animal kingdom. I'll say this one point, and then if you want, you can make a point. We'll move on. Dr. Nathaniel Jeanson, he made predictions on speciation rates based on created heterozygosity, the technical term for God creating the original created kinds, including Adam and Eve, with pre-existing diversity, pre-existing DNA differences. They're created in a state of DNA diversity. And he predicted that new species, new variations could come about through shifts in heterozygosity, so more allelic variability, to shifts in homozygosity, so lesser amounts of allelic variability. Breakaway populations, isolation, inbreeding, so on and so forth would do this. You get enough genetic distinctiveness, boom, you got a new species. Well, they observed that on the Galapagos Islands just several years ago. A new finch species was formed, and genetically it was formed through shifts in heterozygosity to homozygosity, which is exactly what Dr. Jensen predicted or expected to find. But what that means is over time, species are going to hit walls because there's going to be less and less available allelic variability, right? From a couple of wolves to a Chihuahua, for example, your Chihuahuas have very little allelic variability for a lot of additional change. And so my point is, these are not the types of changes that are going to explain the biodiversity on the planet, from single-celled like ancestors to whales, to chimpanzees, to plants, to all life. Those kinds of changes are not, and most of the changes, like you said, brother, they're built-in changes. The pre-existing ability to adapt in light of changing environments. And you know what? Ever-changing environments, ever-changing genomes, ever-changing environments require ever-changing genomes, or else organisms would just go extinct after a couple generations if they don't have the ability to adapt. So anyways, those are the thoughts I have. Anything else you wanted to contribute, Ben, before we move on?
Yeah, it's a good way to design organisms, isn't it? So they can change and adapt when they need to. The only other thing I was going to say about Jensen is that, along with that, is that he noticed that if evolutionary theory is true, then the speciation rate for every species should be the same, which means that as more species are generated, the rate at which new species form should increase exponentially. Because you go from one species, it splits into two. The next, at the same interval, it splits into four. At the same time interval, it splits into 8. That's an exponential increase in the number of species over time. But on the creation model, there's a limit to how far they can evolve, right? And so on the creation model, the more species you have within a biblical kind, the less the speciation rate per species would be, because the niches within the boundaries of that biblical kind would be filled by more speciation events. And what he did was he compared this to the data and saw that, well, we've got a pretty constant speciation rate. It's not an exponential one. That, I think, is a really, really good argument for the young Earth model based on biblical kinds.
You can run the numbers. Dr. Jensen did it on birds. We've got roughly 12 to 18,000 bird species today. We're seeing new finch species in real-time form. If you go back to the origin of birds, 65 plus million years ago, to theropod-like dinosaurs, in light of the fact that we can observe new species today, if deep time evolution were true, we should have hundreds of thousands of new bird species. Yet we actually only have 12 to 18,000, which line up perfectly with new bird species coming about in just 4,500 years since the flood. You can run those same numbers with lizard species, amphibian species, all these different kind of species within the mammal kingdom, felids, canids, and they all line up beautifully with the young Earth creation position. And it's largely because of the mechanisms that are resulting in these variations, consistent with young Earth creation and not deep time evolution. So point out, he can do a slap and run there and just name, well, what about bacteria? What about fruit flies? What about Darwin's finches? But no, when you examine each case, when you look under the hood, as Dr. Kevin Anderson says, and I like it, let's look at what's going on at the genotype rather than the phenotype. What's resulting in this phenotypic change? And you find that it's typically either due to the pre-existing ability to adapt or due to degeneration, right? Adaptive degeneration. So none of this is true evolution, Ben.
No, yeah. Jensen's done really great work. Check out Replacing Darwin if you guys haven't yet.
Yeah, it's a great book.
It's a great book. Really important contribution there.
He made those predictions years ago. Replacing Darwin, I think that was originally published in 2017, I think. I'm just kind of going from memory. So years ago.
It's been a while.
It's been very fruitful. I mean, he's got a whole section there on the speciation rates, the predictions. And I've never seen critics like Creaky Blinder engage those predictions. And that's what we mean, what we said earlier, what I said earlier, that I want to see critics, including theistic evolutionists, actually engage in a sophisticated manner our best arguments, our best points, our best models, like the created heterozygosity model, which makes amazing predictions on DNA function, which we talk about here frequently. So anyways, we could probably talk about those points for many hours. So why don't we continue here and see what else he has to say?
You're ready, brother? I think this is a good segue into your presentation to counter, obviously very comprehensively, what he's asserted here, Ben. So I'll put your slides up on the screen. I see the top 5 scientific evidences of young Earth creation.
Top 5 scientific evidences of young Earth creation. And is that a real Donald Trump quote? Right, okay. Forget the quote, forget the high fives. What really matters now is whether or not these top 5 arguments can stand up to the most recent, repeatable, and multi-validated data points we have in geology and physics today. I'm going to say no, but what do you think? Let me know in the comments.
Hello,
Commercial
I'm
break.
Jason Dunn, painting instructor.
Catastrophic plate tectonics is the best flood model currently available. And if you dig deep enough, most of the major young Earth creationist organizations will admit that. But flood models are notoriously controversial within the young Earth community, but hopefully I can explain to you why this is the preferred model.
I appreciate the ambition, Ben. The problem isn't the model's controversy within the young Earth creationist community. The problem is the controversy within basic physics. There was no global flood. Where the hell did the water come from? And more importantly, where did it go?
But first I need to explain.
Any thoughts, Ben?
I think I explained where the water came from and where it went. Did I not? So
Yeah, I mean,
we never really returned to that point.
that's an aspect of the CPT model. Is all flood models are going to explain
That
where
was a major problem with global flood models for a long time. Even I've been looking at stuff that's like back in the 17th century. Like that was a motivation for the local flood model back then, is they couldn't figure out where the water would come from, right? And then there were young Earth versions that said, okay, here's where the water comes from. But yeah, CPT really solves that because we don't need any extra water on CPT. It's literally just changes in elevation of the ocean floor relative to the continent. So
yeah. Well,
I can't believe he hit me on the fake Donald Trump quote. So, was that not obvious that I made that up? I don't know.
maybe some people are caught off guard due to Donald Trump's personality. Maybe he said that rhetorically, or but
I mean, I'm assuming people are intelligent enough to know that I just was joking there.
right.
Okay.
and one point too, when it comes to competing models within young Earth creation, the exact same thing. It's even worse, depending on the field in the conventional scientific literature, because regardless of what my specific research project is, I spent many months during the last, I would say, quarter of 2025 studying the hominin fossil record and dealing with the Australopithecine question. And it seemed like every paper that I read on the issue in the paleoanthropological community every lecture that I listened to presented by a paleoanthropologist, there were competing models. They were attacking each other's positions. A lot of the finds were contested, different interpretations, especially with fossils. Wow, it's such low quality, low confidence data that you have one interpretation of, let's say, Homo floresiensis, the hobbit, you know, examining the pelvis of hobbit. You got some scientists that are interpreting it one way and others that are interpreting it another way, and model building, both models different. Anyway, so my point is, in the same way that in the young earth creation world, you have competing models, competing explanations, and some in-house debate, you find the exact same thing in the evolutionary community as well. So, you know, it wouldn't be a point against, it's just how science works.
Yeah, it's just more evidence that he doesn't really read the literature as much as he claims to. Right, because the second you read the literature, if you go to the Answers Research Journal and take a deep dive there, or go to the ICC, okay, you're going to see some in-house debate, competing models. That's fun. It's Mike Ord likes to say, point out the importance of multiple working hypotheses, and I agree. But it doesn't take long before you start reading the secular literature, the conventional literature. You find the same thing with a lot of heated debate, actually. So I think you make a good point there, that it's evidence that he's not digging as deeply into these subjects as he should.
Plate tectonics is. So I want you to think of the Earth as a waterbed, like you see before you on the screen. The surface of the Earth, or the crust of the Earth, would be the skin of the waterbed, and the mantle is the water inside. Now, the mantle is technically a solid, but because it's so hot, it behaves like a really viscous or really thick fluid.
Calling the mantle a thick fluid is like calling the Andromeda Galaxy your next door neighbour. While it's technically true, they're both moving, but we're talking about vastly different timescales. If the Earth's mantle were actually as fluid as the water in a waterbed, CPT wouldn't just be fast, it would be over in about a week, and we wouldn't have any continents left.
And so what Baumgartner...
Ben, any thoughts?
I'm really confused. It's like, I said technically it's a solid, and then in his response he goes, well, technically it's a liquid. What? Was he listening to me? I said technically it's a solid, it's just really viscous. Does he know what viscosity is? I just, at this point, I kind of doubt that he does. I said it's a really viscous liquid. That's not wrong. That's correct. And then he basically sort of repeats what I said, except incorrectly.
To score a point with his audience.
I don't understand. I just doubt that he knows even what I was saying. There's other places in this video where the same thing happens, where he repeats what he thinks that I said, and he's just flat out wrong about, because he doesn't understand the concepts that I'm talking about. So,
well, and these are well thought out concepts. I mean, your presentation, the seminar that we did with Dr. John Baumgartner, Dr. John Baumgartner's papers on CPT. I mean, these are really technical articles and technical information. Is really detailed. You know, there's a lot of numbers and physics there that there's just no way that Creaky Blinder can just refute the bigger picture issue here on the CPT model in a short YouTube video. So maybe that's why he's trying to score some points with his viewers by trying to make it look like you were saying something incorrect when you didn't.
Realizes that the surface of the Earth is kind of like this, that the low parts are the crust of the ocean, and they're lower today because they're heavier, they're more dense, and so they sink lower in the mantle, and therefore that's where all the water gathers, because that's lower, and the continental crust sits up higher. Okay, so what Baumgartner proposed is that prior to the flood, what happened was the crust of the Earth underneath the oceans broke off from the continental crust and subducted underneath it into the mantle.
Yeah, denser oceanic crust naturally sinks lower than continental crust. No argument there. That's just basic geology. But the catastrophic part of CPT, where the entire ocean floor fractures instantly and subducts at meters per second, well, that's the part that just breaks physics. Yeah, this one's going nowhere, is it? And why, I hear you ask? Because the flood he keeps mentioning is Noah's flood from the Bible.
No. No, this isn't right.
So not real. You cannot debunk reality with a story from the Bible, Ben. I hope your next argument is a little more based in reality.
Let's continue here. It is probably
Good clip from Bruce Almighty Part 2. Ever seen that movie, Ben?
I have not. I saw the first one.
Yeah, the first one is better. I can't remember much from part, but the first one was funny. Ben, any thoughts there?
I truly, he has a dizzying intellect.
Is it true that he says everything breaks down the second you get meters per second movements of the plates?
He claims
Continental
physics
sprint.
breaks down. Yeah, but that was actually in my presentation, and that was one of the things that there's support for in the secular mainstream literature that he claims to care about. It's literally where Baumgartner got the mechanism for this is from experiments on high pressure, high temperature experiments with crustal rock called olivine. And it showed that the crystal structure of the rock breaks down under high temperature and pressure and actually increases in density, which is the opposite of what you would expect. What you normally expect is as the temperature goes up, the density decreases, like in a hot air balloon. But these experiments showed that with this particular situation, it's the opposite, actually. And so what you get is increasing density at the leading edge of the sinking or the subducting plate that cause it to go faster. That increases friction, which increases heat and shearing force, which increases the effect that makes it get more dense. And so it doesn't break physics. It shows how physics explains how a substance that's getting more dense will sink faster and with more force into a gravitational field. Gravity is physics, and gravity is the energy that's causing the subduction to occur. But, I don't think he understands that part of the model at all. So, whatever.
good that you save the salt accumulation as an honorable mention, because you do make that point here, and then Creaky Blinder tries to refute it.
I think what you meant to say was Creaky Blinder does refute it. And I'll do it again right now. I just need to hear you say the words.
That the rate at which salt accumulates in the oceans because of runoff from the continents, salt dissolves into rivers and runs off into the oceans. And so salt is but when water evaporates from the surface of the ocean, the salt doesn't evaporate. So it leaves the salt in the ocean and the water cycle continues.
But isn't that just based on the assumption that salt goes in but never comes back out, which is wrong? Because in reality, the ocean is in a constant state of dynamic equilibrium. Salt is constantly being removed through various natural processes. For example, it gets incorporated into new rock formations, trapped in sedimentary layers, and even blown out to sea by sea spray. All these mechanisms prevent the never-ending build-up that the creationist argument relies on. So in short, they're only accounting for half the equation, probably because the other half completely destroys their claims. Now, if memory serves, I think the core claim here is that the oceans should be solid blocks of salt if they were 4.5 billion years old, because salt keeps flowing in. But I'll let Ben explain his version, and then I'll explain why he's wrong again.
Okay, so right off the bat, I would say even if we granted him generous rates of salt removal, the net effect still favors salt accumulation, not removal. Therefore, the evidence still points to a young world or a young Earth.
The young Earth creationist argument is based on a simple static model that assumes the input rate is constant and the removal mechanisms are negligible or irrelevant over long periods, which is completely wrong. If the Earth were only 6,000 years old, the oceans would only have roughly 18.3% of the salt they actually contain in reality. In other words, a 6,000-year-old ocean would be much less salty than it is now.
You already made a difference. Now
The commercial break is telling us maybe that's where we should stop to get a bit of a response. Are you convinced? Are you persuaded, Ben, by Creaky Blinder's attempts to counterbalance the salt accumulation problem, sea spray, and these other geologic processes for salt removal?
I mean, he needs to learn how to listen. In that presentation, I put up something from the young Earth literature, which he refuses to read, that showed all of the documented or assumed or calculated inflows and outflows of salt into the ocean. We claim that the outflows are negligible. We claim no such thing. It's not negligible. It's significant. It's just that the inflows are more than the outflows.
Exactly.
We didn't say the outflows were negligible. When you say something is negligible, it means you're treating it, it's so small that you can treat it as zero.
Yeah.
I clearly did not say that. We're just saying the inflow is bigger than the outflow. He also claimed that I was arguing that eventually on an old Earth model, the ocean would become some solid block of salt. That's not what I said at all. I said it would have reached the saturation point by now. And if he knew any chemistry at all, he'd know that a saturation point just means that's the most possible salt that could be dissolved in water. It's not a solid block of salt, but I don't think he knows what a saturation point is. So in his head, he assumed that's what I was saying. What else? He claimed that on the young Earth model, there's not enough salt in the ocean, right. or the young Earth would predict less salt, I think, in the ocean. Neglecting what I'm sure I said in that presentation is that I acknowledged that and said we think probably either God created the oceans with some salt in it already, or there was a whole more likely, in my opinion, there was a whole lot of salt that was added at the flood, which you'd expect.
Yeah.
With the kind of event that the flood is. So he just ignores all that. I don't know. I think that's all I had there.
Fountains of the Great Deep breaking open, bringing in a lot of different mixtures of chemicals, and and I've discussed this with many young Earth creationist geologists, that there's good explanations for many features that we find, like limestone could be rapidly formed during the flood, fountains of the Great Deep breaking open, and other processes associated with the flood. But if I could break it down simply, the way I see it, and we never said negligible, and maybe this isn't the best analogy, I don't know, we'll get your thoughts on it, but if I'm sinking in a fairly small boat in the middle of the ocean, and there's a pretty large hole in the boat and water's gushing in, okay? But even if I had a large bucket and I'm just trying as fast as I can to remove the water from the sinking boat, okay, it's not negligible because it's a pretty I am removing water, okay, but the amount of water that's actually gushing in, I'm never going to be able to counterbalance and save the boat and save my life. So although not negligible, there's certainly no counterbalance. And so the salt removal mechanisms that he talks about, they exist, they're real, but they're not doing anything to resolve the issue. Kind of like genetic entropy in a way. Okay, selection works, sees some mutations. I would agree that there are some beneficial mutations because it's context dependent. Even the majority of so-called beneficial mutations, firstly, they're rare, they're reductive, usually functionally compromising, but maybe you get a rare one that's not. Okay, that's not negligible. It happens, it's real, but they're not going to do anything to counterbalance the many millions of slightly deleterious mutations that are pouring in and eroding genetic information and bringing species downhill. So anyways, hopefully that makes things a little easier to understand for the audience. But point is, yeah, it's not negligible. We never said that, but there's just no counterbalance. And this could apply to many different things that we could discuss. Ben, in your opinion, does that accurately reflect it, or what are your thoughts?
Yeah, it's just the inflows are greater. It's a bigger number than the outflows.
Which doesn't mean that the outflow is negligible or zero.
Right.
It's just that it's not solving the issue, right?
It's not. It doesn't solve the issue for the old Earth position.
Yeah, it's good. So it's the way I see it. I don't think it's that complicated, and he's trying to overcomplicate it. But okay, let's continue.
Well, he is right about that. There are several mechanisms, and if he had read the creationist literature, he would know what they are.
Ah, silly me. That's why I'm wrong, because I didn't read the
See, he's rhetorical here, but it is a very true statement that if you actually read and this is why.
One second.
Yeah,
I literally in that clip said he's right about that. And then he says that I'm saying he's wrong. Does this guy not listen? What is going on? I don't understand.
Or he's basically saying, okay, well, he says I'm right, but Ben's just saying that it's all meaningless, negligible, zero. So he's right, but it doesn't matter. But that's still a straw man.
He won't even let me be charitable to him by saying he's right. Like,
he ain't looking for no charity, not from some silly creationists. And this is why credit where credit is due. You know, some critics like Gutsy Gibbon, who we go back and forth on quite a bit, critics like that, they're pretty good at actually reading the young earth creationist material, watching our presentations, lectures. In my opinion, that's how we can best engage in discussion, debate, and dialogue, is by understanding each other's. I make it a mission to understand the evolutionist side better than the evolutionist. I spend a lot of time studying their arguments, reading their literature. If we're not reading the other side's literature, then we're going to be more prone to straw man arguments. We're going to be more prone to repeating arguments that aren't good. Over the years, Ben, let's say, 7 years of doing this or so, I've actually abandoned some arguments in favor of others, abandoned some models in favor of others, because engaging in discussion and reading the other side, looking at both sides, have helped me personally to refine my position. It's helped me to realize what works and what doesn't. But you're not going to be able to do that if you're not looking at both sides. Looking at both sides is just a given. It's just something you got to do.
it's something you would do if you care about the truth, right?
Well, but he already said at the beginning, he has the truth. So that's it. He doesn't have to look at the other side.
Yeah, if you cared about clicks and views, you might not do that, I guess.
Yeah. Spot on. Okay, we're moving along smoothly. Let's keep going.
Creationist literature, but I can explain in simple terms why I didn't read any of the creationist literature.
Oh, he's leaving us in suspense. Why doesn't he read the creationist literature? Comment. Here we go. Commercial break is over now.
If that's helpful, it's because when I need to look up a scientific fact, I tend to favour actual science papers and scientists. Now, if you're getting your information about science from a religious organisation, then you're doing it wrong. But it does explain a lot about why your points are so easily debunked.
But we clearly showed that.
What are your thoughts, Ben?
Doubt that he reads the scientific literature.
Yeah, he's not reading either side.
Yeah. But I mean, you were spot on earlier about the, you engage critics because you want to hear the best criticism of your own position to see if you're wrong and need to change your own view. That's why you engage critics. I've done the same thing. I've changed my views a few times. Yeah, I think he should try doing that once in a while.
And you'll hear, as you've heard, but when you hear a lot of these creation scientists speak, Dr. Andrew Snelling, I'll use one example. When he gave his seminar a few months ago here, they went in the RATE project, radioisotopes in the age of the Earth, with a prediction. Okay, take helium, for example, or C14, right? If the Earth is young, here's what we'd expect. If the Earth is old, here's what we'd expect. Where's the bias in that? I mean, okay, here's what we would expect. Now let's go in, look at the data. Then they get the data, like the helium and zircons. I mean, they took those zircons to secular labs, and the way it's been explained to me that, they weren't necessarily the happiest when they found out that these were young Earth creationists doing it, but they literally won't test these samples, whether they're diamonds or zircon crystals or whatever. They won't test them if it's a young Earth creationist requesting the test, because when it comes back in favor of young Earth creation and contradicts the old Earth model, well, that's a problem to that for them. They don't really like that. But anyways, my point is, this is real science. So he wants to say, well, I'm not going to go read anything put out by a religious institution or a scientist who has a religious worldview. Isn't that him showing his bias, Ben?
Yeah, I remember when Francis Collins, who we don't really like, but he is a Christian, was appointed as a director of the National Institutes of Health. Sam Harris, one of the four horsemen of atheism, wrote a column in the New York Times arguing that Barack Obama should not appoint Francis Collins to that position because Francis Collins was a Christian. And because he's a Christian, he can't do science as well as non-Christians. And the head of the NIH is such an important position that we couldn't allow a Christian to have that position. This bias goes deep. It has to do with naturalistic assumptions where they think that you have to assume naturalism in order to do science at all, which is just totally bogus. You'd have to, eliminate 80% of the science that has been done in the world, which is what he accuses us of doing. If you were to eliminate Christians from doing science because they believe in a God or something, I think this is a fading view. I think it is rightly being rejected even by atheists today, to take this sort of militant stance against Christians. So,
yeah, I agree. It's a good point. Okay, here we go.
All he has are rescue devices. He still has to do his homework. And when we even give him everything that he wants, everything that he needs, it's still a problem. It's still something that needs to be resolved. Sam, you're going to say something, brother? I'll go mute this.
Yeah. I just wanted to compliment him on his rhetoric game. That is on point, right? I'm going to give him that. I think he's got good rhetoric.
Yeah, we'll give him the rhetoric. We'll give him a point for rhetoric. 99% rhetoric, maybe 1% substance.
Oh, thanks.
Another one, if I had time, would be the cold spots they found in the mantle, Earth's mantle near the core. These are measurements that are made where they...
So, Ben, this is going to be a big one. It's going to be a major one.
Is it? We'll see, won't we? Because if Ben mentions the Bible again, I'll just be moving on to the next point.
And so let's allow him to make his arguments, or we'll let him...
So he won't even allow us, which means he is going to hand wave away or dodge, duck, dip, dive, and dodge, the 5 Ds of evolutionist dodgeball. I had some evolutionists comment on one of my Facebook posts or comments. Oh, you can't even get that right. You said dodge twice. And I was like, listen, man, if you don't understand the movie Dodgeball reference, you dodge, duck, dip, dive in. And you ever seen Dodgeball? And then Hank Azaria, I think it was, he was doing the training video. He's like, just remember the 5 Ds of dodgeball, son. Dodge, duck, dip, dive, and he forgot the 5th one. So he says dodge a second time, right? So it's a dodgeball reference. But yeah, a lot of these evolutionists do this because notice what Creaky Blinder said. Well, if he mentions the Bible, then I'm just going to ignore it. So when we say things like, okay, the Bible claims to be the history book of the universe. The Bible claims that there was a worldwide flood in the past. The Bible claims that Adam and Eve were created special and independent. Let's go look at the scientific data and see if it lines up with that. That's pretty important. I mean, the scientific data could have overwhelmingly contradicted what the Bible teaches about origins. But the fact that it lined up so beautifully means that if a critic like Creaky Blinder is going to sufficiently or adequately refute us and our arguments, he can't just ignore those points. he needs to counter the evidence that we're looking at to show why we can trust what Scripture says. Anyways, Ben, what are your thoughts?
My first thought is I'm wondering how many videos of us we can get on one screen here.
Yeah, sometimes it throws me off.
Yeah, because you were talking in the middle one, and I'm like, do I need to? Oh no, that's the.
I'm wearing the same shirt in every single one.
Yeah, I have like a different hair.
You have a different hairstyle. Eventually, if we move forward a year, Ben,
there should be 6 or 7, right?
Yeah, we're gonna keep going back with Creaky Blinder. It's gonna be 6 or 2. We're gonna be taking a nice deep look into the multiverse.
Yeah. The other thing is kind of just something I would say as to all of this about critics and stuff is there are two critics of young Earth creationism that I would recommend to people, including young Earthers, and that is Gutsick Gibbon, Erica, and Joel Duff at the naturalhistorian.net, I think is his website. So I will plug those because they read enough of the young Earth creationist literature that a lot of their articles, you'll learn more about the young Earth position than you do on quite a few young Earth sites. Not yours. You do a good job too.
Well, I see what you're saying, because I've come up with my own arguments or explanations for things. One example, the Australopithecine question. I probably consumed more of Gutsick Gibbon's material on hominids than Cretaceous material, and she engages Cretaceous material, and then I've come up with what I think are good answers. But the point is, those are a couple of YouTube channels featuring critics where they've actually done what Creaky Blinder is so opposed to. They've actually taken the time and put in the work and energy to look at both sides.
Yeah, so I definitely won't be recommending Creaky Blinders to anyone.
Oh, I thought Creaky Blinder was going to be going to your top recommended just for his rhetoric, which he was proud of Sam to give him a point for that.
Speak for a minute or two, and then we'll throw it over to you to get your overall thoughts on what he's saying. Is he misrepresenting it? Do his rescue devices work? So on and so forth.
Am I misrepresenting what? Reality? Relax, Donny. I'm not misrepresenting anything, pal.
For temperature based on the motion of the material down there. And they found these cold spots that are something like, I think, 500 to 1,000 degrees Celsius colder than the surrounding mantle.
The claim goes something like this. These cold spots exist, and if the Earth were billions of years old, everything would have completely equilibrated by now. Therefore, the Earth is young. It's a textbook straw man. The cold spots exist. That part is true. But the reason they exist completely disproves the creationist argument. Imagine a huge cold slab of rock from the Earth's surface being shoved down over millions of years into the superheated molten rock of the mantle. That's exactly what's happening. The sinking plate is still a different temperature from the surrounding mantle, and it takes a very, very long time for it to heat up, which is what we are detecting. The cold spots are not evidence of a young Earth. They are direct evidence of plate tectonics in action, and you cannot have subduction, a process that happened at a snail's pace over millions of years, in a young Earth. I think that was a pretty solid explanation, but go on then, lads. I could see the three of you concentrating. Tell me why I'm wrong.
But what he did say is he's assuming that the rate of subduction is the same as it has been observed today.
Oh, you're a liar. Or at the very least, you've just misrepresented what I said. I said no such thing.
And that's not the model. We're saying that it probably occurred faster in the past. And we presented evidence for that. And part of the evidence is that there are cold slabs down there.
But that's just circular reasoning, Ben, and as I've debunked this in the video you're responding to, I'll just say this. The cold slabs argument is actually much weaker for a young Earth than you seem to think, because the mantle is an incredibly poor heat conductor. The old Earth model, or as I like to call it, reality, uses observed slow subduction rates and still accounts for the existence of cold subducted material.
Because aren't you showing that no, it couldn't have occurred slowly? Because if it actually did, if that's what we're going to, because he's saying, oh, this is evidence for plate tectonics over millions of years, but if that really were the case, then these cold slabs that we find in multiple locations in the Earth should have actually warmed up or even melted. But the fact that they're cool actually supports what we're saying and what you presented on, Ben, that no, this is plate tectonics, but it's rapid plate tectonics, not the snail pace movement of the plates through the floodwaters, but the continental sprint, as I've heard some people describe it, meters per second movements. I think we're moving into the final point, the helium and zircon crystals. So we've moved along smoothly.
Well, did he address that? I don't know. Any thoughts on all that? It sounded like he was basically saying that the cold slab data, well, that the mantle's a poor heat conductor, so we wouldn't expect the cold slabs to assimilate or melt. And then secondly, we can't explain the movement of the continents or plates in 4,500 years, which you've addressed. And lastly, he even asserted that the cold slabs work against the young Earth creation model. So Ben, are we tapping out on the cold slabs or what?
Oh yeah, I give up. I mean, if it's true that the mantle is a poor heat conductor, but the question is going to be numbers. So he needs to show numbers that show that on the old Earth model, it would not have equilibrated by now. He needs to give an alternative model. And if it was true that the numbers would work out that way, that'd be a really easy and simple solution. So why haven't we seen it from the actual old Earth affirming scientists? We've seen responses to the cold slab thing claiming that, well, the measurements that we make of these spots in the mantle, we have to infer the cold temperature, but it might not actually be cold temperature. It might just be the convection currents are slower for some other reason in those areas. That's a response I've seen. But if it was easy to accommodate the old Earth model by just simply showing that it wouldn't equilibrate over billions of years, and why hasn't anyone done that? And again, did he get this from the mainstream scientific literature that he claims to read about this stuff? If so, let's see it, man. Let's see the papers that you read that showed this. I think
let's see the numbers. Let's see the because have you noticed the critics like to challenge us? Where's the numbers? Show me the numbers. But then they can make an assertion, but don't need to show the numbers. I mean, that's kind of a double standard or a little hypocritical. So, yeah. Okay. I think those are good points. The last 2 minutes, because, it's almost 12:30. We're almost going on 4 hours. Ben hasn't even taken a single break or restroom break. So that's impressive, brother. That's something you've endured to the end. So,
I think I'm just a little tired, so I kind of don't want to get out of my seat.
yeah, I don't blame it. You know what? As soon as we end, you can just roll back and fall asleep till the morning. Then we'll do some more refuting of the critics. So the last 2 minutes is the helium issue. Okay. He does largely dodge it. People can see it himself, but he put out a follow-up video just a week or so ago. So on my own, I'm going to work on kind of responding to the last 2 minutes and then his follow-up video at a future date. I think we provided more than enough content, more than enough of a response for Creaky Blinder to digest and hopefully convert from the idea that he's related to a banana plant. The evidence for young Earth creation is powerful. We've got good, solid answers to these challenges, as you've demonstrated so well here tonight, Ben, my brother. Relativity and distant starlight. Wow, what a marathon. This has been an excellent program. As Doki Doki says, Ben has true grit from Nebraska. So you killed it, brother. Let's hand it to you. Final words, final thoughts. Have you converted to evolutionism because of Creaky Blinder's video and some of the objections and challenges that came in on distant starlight, Ben?
I admit that being descended from a banana plant might be a good explanation for him personally.
He might say, no, me and a banana plant, we go back to a common ancestor.
And he's got gauges in his ears, so I think he can take the backhanded insult there.
Yeah. He's got a good sense of humor, that I can tell.
He's a tough enough guy.
He's been jabbing us and we're laughing it off because we appreciate a little bit of rhetoric. Not too much rhetoric, but a little bit of it. Well, Ben, you did a good job, brother. Any final words, final thoughts? I appreciate the work and time that you clearly put into your presentation. Every time you're here, these programs are very comprehensive. William Lane Craig, Redeem Zoomer, Creaky Blinder now a couple times, Distant Starlight. Am I missing any critics? Inspiring Philosophy. We can't forget about our good friend Inspiring Philosophy.
I briefly met him in Boston, by the way. I don't think he knows who I was, but
he was thinking that's that guy who's debunked me all over YouTube, and I can't.
That guy who I blocked on Twitter, so I don't know even what he is or who he is anymore. So,
well, you've won the debate when you're forced to ghost, block, silence.
Yeah, it's like if your business model is based on being right about everything, and someone comes onto your socials and wins an argument with you, you can't have that.
Right. So you got to block, got to ghost him, got to silence him.
Got no
somehow.
choice. You're gonna lose followers if that happens. You'll lose your mystique of being right about everything.
That's right.
So
Ben,
anyway,
you did a good job. I've got all your socials here, all the links. Macrophage strategy. There's your bio, YouTube channel, your X account where you trigger all the liberals and evolutionists and atheists. Your review of William Lane Craig's book. So there's a lot for people to check out. Doki, thanks for those links.
Yeah, I think the main thing would be to check out my podcast. And so on there, I kind of, like, when I get done here, I'll put the link to this video on my next podcast in the description. And that's kind of my central place where I release.
Is it this one here? Podbean, Open Spotify?
Yeah, but it's probably just easier to go on Spotify, or I think I'm on several other platforms, including the Apple Podcasts, Amazon. I think I was on Stitcher. I have to check that again. But if you just go on Spotify and search for my name, you should find my podcast.
Okay, well, very good, Ben. This has been a ton of fun. Like I said, ultra marathon. Relativity and distant starlight, and debunking Creaky Blinder. That was a good response. I mean, we got through essentially 18 minutes of it. For those wondering how Creaky Blinder addresses helium and zircon, stay tuned. I'll be at some point putting out a response to that. And okay, Ben, this was fun, brother. Thank you to everybody who participated. I'm looking at the starred section. That's the section with all the comments and challenges. And I appreciate the enthusiasm from our live chat. We've had a good mix of critics and non-critics, and that gives us the opportunity to be as comprehensive as possible on this issue. Ben, you gave a thorough presentation on the ASC model, and then we spent quite a bit of time engaging comments and interacting with challenges, which is exactly why we like to do these live, because we want to interact with you guys. Okay, God bless you all. We'll be back here. We've got events almost every single day this month, guys. So we'll be back tomorrow for a debate. So we got 2 debates back to back. Tomorrow is Friday. So Friday, we've got Christian versus Muslim debate. And then on Saturday, we've got a debate here on the atonement, it looks like. Does Christ's death automatically or conditionally take away sins? And then on Monday, I'll be back here with Gavin Cox, which I'm excited for. We're from Answers in Genesis UK. We're starting another series, 2-part series on the truth about Egyptian chronology. Should be fun. I'm excited. Okay, God bless you all. Ben, excellent work as usual, brother. Standing for Truth is signing off.